Big news! The Large Hadron Collider is being switched off. That sounds scary, especially if you've heard the old rumor that this machine would create a black hole and destroy Earth. Wait, is it finally happening? Is that why they're shutting it down? So, the Large Hadron Collider, or just the LHC, is the biggest science machine ever built. It's a giant ring-shaped tunnel deep underground near Geneva, where scientists smash tiny particles together at crazy speeds. They do it to copy, for a split second, what the universe was like right after the Big Bang. By recreating those conditions, the experiment could reveal some of the universe's deepest secrets. And now, this iconic machine is shutting down. It won't be permanent though. They have to power it down so the team can do major engineering work and install some big upgrades. And that process will take around 5 years. Scientists guarantee the LHC isn't shutting down because of a problem. If anything, the machine is still working great and gathering massive amounts of data. But don't get it twisted. The famous atom smasher isn't going to run forever. It will probably retire around 2041. And after that, it may be replaced by a massive machine called the Future Circular Collider, or FCC. But before we explain what's coming next, let's talk about how the Large Hadron Collider actually works. This is the world's most powerful particle accelerator. Think of it as a metal ring buried deep underground right under the border between France and Switzerland. And it's huge, around 17 miles around. It was built to answer a very old question. What is everything made of? Basically, the LHC lets scientists recreate conditions similar to those right after the universe began. Inside this ring, scientists send tiny particles racing around at almost the speed of light. These particles are like microscopic race cars, guided by powerful magnets that bend and steer them around the loop again and again. As they go faster and faster, they carry enormous energy, even though they're unbelievably small. At certain points around the ring, scientists smash these particles together head-on. When they collide, they break apart and turn into showers of other particles. Scientists record everything they can about those conditions and basically hope it helps answer some huge questions about the origin and structure of reality itself. This $10 billion project began in 1989 and became operational in 2008. Then, in 2012, it made a major breakthrough by discovering the Higgs boson. This is a fundamental particle associated with the Higgs field, a theory first proposed back in the 1960s. To understand it, let's use a rock and a light. Both are made of particles. Now put them on a scale. The rock shows up right away. It has mass, so it has weight. But you can't really weigh light on a scale because it doesn't weigh anything. What I mean is that some particles are massless, or close to it. Take photons, for example. They carry the electromagnetic force and have no mass at all. Same goes for gluons, the particles that help hold matter together. But plenty of other particles do have mass, and for a long time, the big question was, where does that heaviness come from? This theory says there's something spread throughout the entire universe called the Higgs field. Some particles interact with it more than others. The more they bump into it, the more mass they end up with. Photons and gluons, on the other hand, don't interact with the Higgs field directly, and that is why they don't get mass from it. So, discovering the Higgs boson particle is basically the big clue that this field is real. But here's the thing. Elementary particles get their mass from the Higgs field, but nobody really knows why different particles end up with such different masses. Actually, we don't even fully understand how Higgs bosons interact with each other. To help answer those questions and a bunch more, scientists need to upgrade the LHC. The plan is to shut it down now for the next 5 years to build the, drumroll please, high luminosity LHC. Basically, that means installing powerful new superconducting magnets that squeeze the proton beams and make them more intense. That should boost the number of collisions inside the machine by about 10 times. The detectors are getting upgrades too. so researchers can spot even subtler signals and catch hints of new physics hiding in those collisions. So the whole team is crossing their fingers that the upgrade will go as planned. Because with these changes, the LHC will be able to make more precise measurements of particles and how they interact. And that could reveal cracks in what we think we know about the universe. Now you can see why this machine makes some people nervous, right? Some worry it could destroy the world by creating mini black holes, strange matter, or even vacuum bubbles. Basically, doomsday scenarios. But experts say there's no real risk of that, or at least it's extremely unlikely. Either way, you don't have to worry about them turning it off. Nothing bad happens when the machine stops, and we know that because this isn't even the first time it's taken a vacation. The Large Hadron Collider has already gone through 2 major multi-year shutdowns for maintenance and upgrades. One happened back in 2013 and another in 2018, so the shutdown planned for 2026 will be the third one. In other words, yeah, these kinds of pauses are pretty standard, so there's really no reason to panic. Over the next few years, the team will be focused on getting the high luminosity LHC up and running. But at the same time, some much bigger and more controversial projects will also demand their attention. Like we mentioned earlier, the LHC won't last forever. At some point, it'll likely be replaced by something even bigger, the Future Circular Collider, or FCC. We're talking about a brand new circular tunnel with a circumference of about 56 miles, dug as deep as about 1,300 feet underground, and it would be built in 2 stages. The first stage, starting in the late 2040s, would collide electrons with positrons, which are basically their antimatter twins. Then, sometime in the 2070s, that machine would be taken out to make room for a new collider that smashes protons at about 7 times the energy of the LHC. Building something this huge would cost a ridiculous amount of money, sure. The estimate is around $18 billion, and that's just for the first phase. But the team believes spending that much money will be worth it. They say this new machine is necessary to answer even deeper questions, like what role the Higgs field played in the evolution of the universe. Or maybe it can help explain the nature of dark matter. And what about the imbalance between matter and antimatter? To get answers like these, scientists would need to create conditions that point to the existence of new, much heavier particles. Particles that the current Large Hadron Collider simply isn't powerful enough to produce. The Future Circular Collider still has some big technical challenges ahead, but a lot of groundwork has already been done to shape the project. CERN, the European Organization for Nuclear Research that runs these experiments, has already completed an extensive feasibility study. The report confirmed the project is technically doable, and it laid out the next steps towards a detailed design. Right now, this study is being reviewed by the CERN Council, and around 2028, they could decide whether to move forward with the FCC. So for now, the LHC is shutting down for its next big upgrade, and someday it will shut down for good. Not because it failed, but to make room for something even bigger and more powerful. If the next machine gets built, maybe it won't just smash particles. Maybe it'll push us a little closer to the biggest answers of all. Like, what are we? And where do we come from? And yeah, that's pretty exciting.
For decades, time travel has been dismissed as impossible. But this physicist just cracked the code using quantum mechanics. He's trying to prove that time loops might actually exist without breaking reality. So could this be the first real step toward building a time machine? In everyday life, we're used to time moving forward in a straight line. It goes from the past to the present to the future. That's how people saw it before Einstein, because that's how it feels to us. But when Einstein showed up, he told a very different story. He showed that both space and time are woven together like some flexible fabric into one thing, called space-time. Space itself can bend and twist, and time does the same with it. The fabric of space-time bends and gets curvy when we place heavy objects in it, like planets, stars, or black holes. The heavier the object, the more it will get stretched and bent, slowing down time around it. Movies like Interstellar showed it pretty well, even though the characters only spend a few hours on the planet. When they return to the spaceship, 23 years have passed for the astronaut waiting there. Why? Because the black hole's extreme gravity warps this fabric of space-time itself, and the closer you are to it, the slower things go for you. Sounds insane, but that's how our universe works. And that's not just black holes. All massive objects, like the sun, for example, bend the fabric of space-time around them. This is also why planets orbit in curves. All this gave physicists a pause. If we can bend space-time, can we bend it to such a way that we'll make a loop out of it? It would be like going on a journey that bends back on itself, meaning that if you followed it, it could return to the past and experience the same moments again. That would be pretty insane. Imagine that you walk down a hallway expecting to exit through the door at the end, but instead of a door, you find yourself standing right back where you started, walking into your past. But just imagine how hard something like that would be to pull off. Yes, heavy objects can stretch and twist space-time, but even those massive things still don't loop time. They just slow it down very strongly. It's hypothetically possible, but it would require super extreme conditions. For example, if the black hole gets a little extra boost, spinning, it could theoretically bend space-time around it into a loop. There are also some wacky ideas, like exotic matter and wormholes, but they're all speculative. But let's assume that there is a way to make a CTC. Creating it isn't our only problem. This is where the paradoxes begin. If a time loop could exist, wouldn't it create contradictions? The grandfather paradox is just one example. If you follow a big loop like that and accidentally prevent your grandfather from meeting your grandmother, you'll make it mean that one of your parents is never born, and you weren't born either. So how could you travel back in time in the first place? Or what happens to you after that? There are other ideas like that, like destroying your time machine before you use it, or giving William Shakespeare his own plays. There are infinite possible paradoxes. All this is happening because of entropy. It's one of the main laws of physics, this idea that chaos in the universe always increases. Things start as something normal and structured, but eventually they break apart, becoming weird and chaotic, and can never go back. Ice melts but never refreezes into its original shape on its own. Our bodies age instead of getting younger. We remember the past, but not the future. All these are examples of entropy. So, like, if time travel were possible, how would entropy behave? Would a broken glass fix itself? People would grow younger, and people would lose their memories? That's exactly how paradoxes like grandfather's paradox are born. Well, this is where the recent theory changes everything. The physicist Lorenzo Gavassino has a cool idea to explain this issue. He tackled quantum mumbo-jumbo, working with something called quantum fluctuations. See, the universe is never completely still. Even in empty space, at the tiniest level possible, there are constant random changes in energy. These are those quantum fluctuations. They're like tiny, unpredictable jitters that pop in and out of existence. Yeah, our universe is just weird like that. It's like a lake. On a normal scale, it looks smooth, but if you zoom in super close, you'll see tiny, unpredictable ripples forming and disappearing all the time. Our universe is the same with quantum fluctuations. These fluctuations happen everywhere, and they become really important when dealing with stuff like black holes and time loops. Now, back to the time loops. Gavassino says that in a time loop, quantum fluctuations mess with entropy in a strange way. Ideally, the chaos should increase. As usual, we're getting older, our spacesuit is getting weary, broken things don't fix themselves, and so on. But it seems like instead of always increasing, chaos in a time loop can randomly decrease. This means things that should be irreversible, like aging or breaking something, could actually reverse themselves. So yep, if you try doing something wild during time travel, it won't really work. If you try to prevent your grandpa from becoming your grandpa, the universe could reverse that change, making it like it never happened. If you travel to the past, your memories could vanish, meaning you wouldn't remember the future you came from. And if you try to break causality, the universe might just remove the contradiction. Time would always find a way to correct itself, preventing paradoxes. Scientists actually suspected this for a while now. Many of them have believed that if time travel were possible, the universe would somehow prevent weird paradoxes. Basically, it would make sure that everything that happens must be logically consistent with itself. Well, Gavasino's work basically gave a mathematical proof of that using quantum mechanics. Of course, there was another wild theory, the one with multiple universes. You definitely saw this in the movies. It says that when we travel back in time and change something, we simply create a new timeline. The old one remains, but this one would go a completely different way. But this idea is more about cool sci-fi than actual math and physics. But does that mean that time travel actually exists? Well, not right now. Even if time loops could exist in theory, that doesn't mean they actually do exist in real life. Stephen Hawking, for example, thought that these time loops are impossible. He said that the universe works in such a way that it would simply prevent time loops from forming. He even organized his famous time traveler party. Unfortunately, no one showed up. But many physicists still believe time travel is impossible, at least on a macroscopic scale. They even kind of managed to do that. For example, teams from Oxford and Vienna wanted to see if they can reverse one single electron back in time. And they managed to do that inside of a quantum computer, though the effect was tiny, only a fraction of a second. Recreating that normally would be absolutely insane. If we wanted to see something like this naturally, we would have to observe 10 billion electrons per second for the entire age of the universe. And even then, we'd only see it once. The more particles they tried to rewind, the more errors appeared. With one tiny electron, it worked well, but when they got to 3, accuracy dropped in half. But even if we never find a way to travel through time, understanding all these things could still help us a lot. It would help us study black holes, the early universe, and even quantum technology. So, while time machines are still science fiction, this research is pushing us closer to understanding our universe. This whole part of our planet has disappeared. It used to be a tectonic plate, but something that big doesn't just vanish without a trace. And the clues that led to its discovery started in this mysterious gap between South China and the island called Borneo. For a long time, people thought the sea between these two places sat on a tectonic plate called Izanagi, which no longer exists. But wait, how does a tectonic plate just vanish like that? Alright, tectonic plates are like pieces of a puzzle all connected together. But instead of sitting on a table, they're floating on this semi-fluid layer. So they're always shifting and bumping into each other. And there's something else. Some pieces of this puzzle are heavier than others. And what happens is that eventually, a heavier piece slips under a lighter one. Something similar happens with tectonic plates, but it's less about weight and more about density. When the edge of one plate sinks below another and gets pushed down into the mantle, that process is called subduction. But it's not just the edge that can sink. Entire massive plates from the past have completely vanished into the Earth's mantle. That's exactly what happened to the Izanagi plate. About 130 million years ago, it started sliding under the Okhotsk plate, getting swallowed little by little. By around 55 million years ago, it was completely subducted and replaced by the Pacific plate. And for years, specialists thought that the ocean between China and Borneo was sitting on that plate before it disappeared. Cool, but the experts got it wrong. Turns out the ocean between these lands wasn't sitting on the Izanagi plate after all. Instead, it fits into this weird, unexplained gap, as if a piece of the puzzle was missing. Recently, researchers at Utrecht University finally discovered that this gap was actually a ghost tectonic plate that no one knew about, the Pontus Plate. It got its name because back when it existed, it sat beneath the ancient Pontus Ocean. But if it vanished so long ago, how did experts find it, right? Luckily, tectonic plates sometimes leave traces before they completely disappear. But instead of investigating footprints or fingerprints, it's more about looking for rocks. Yeah, stones from a lost plate can get incorporated into mountain ranges and show us where those ancient earth layers were. That's because rocks have a special power to record Earth's magnetic field. You know, that invisible shield that protects our planet from space threats, like solar wind and cosmic rays? So, as rocks cool and solidify, the magnetic materials in them, like magnetite or hematite, line up with Earth's magnetic field at the time and get locked in. They can freeze a record of the magnetic field direction and strength. And since it changes depending on latitude, basically whether it's further north or south on the planet, it allows the rocks to kind of take a snapshot of their ancient position relative to the equator. Knowing this, researchers traveled to Borneo to collect and study the rocks over there. And they discovered something odd. These stones were originally from a much farther north region. Their ancient coordinates didn't match the latitude they expected for Izanagi. In fact, they didn't match any of the tectonic plates we knew about up until then. So they quickly realized two things. One, they had just discovered an eerie gap. Two, there must be a hidden ghost tectonic plate that used to be in that spot. To unravel the mystery, scientists used computer models to study the region's geology over the last 160 million years. Thanks to this technology, they were able to piece together the entire Pontus Plate in all its glory. The next step was to figure out the key features of this part of our planet that had been submerged, like its age. You see, the rock samples collected in Borneo date back 135 million years, back when dinosaurs ruled the Earth. With this information, scientists realized that the Pontus Plate was formed at least 160 million years ago, but it's probably even older than that. Although it is hard to pin down exactly when it was formed, one thing we can say for sure: it was huge. The Pontus Plate was about 1/4 the size of the Pacific Ocean. Unfortunately, by around 20 million years ago, it said bye-bye to the planet, sinking and being completely pushed under the Australian plate to the south and China to the north. At this point, you might be wondering if a couple of rocks and a computer reconstruction are enough to prove that the Pontus Plate really existed. Well, yeah, they are. But other clues have also been found in Palawan, an island in the western Philippines and in the South China Sea. The truth is that the scientific community has suspected the existence of Pontus for over 10 years. At that time, researchers were really focused on the area around the Philippines. This region is like a playground for geologists, since it sits at the crossroads of several tectonic plate systems. So, scientists decided to reconstruct the movements of the Earth's crust between Japan and New Zealand. And because of that, the study suggested there had to be a subduction zone running through there, separating the known Pacific plates in the east from the hypothetical Pontus Plate in the west. These previous predictions were possible because tectonic plates are really bad at playing hide and seek. Like we said before they get submerged, they leave clues behind. And it's not just rocks. They can also change the Earth's mantle, which leads to the formation of volcanoes, earthquakes, and deep ocean trenches. For example, But the subduction process can also mess with the composition and temperature of the mantle, making some areas hotter or cooler. These are considered anomalies. It is possible to detect these anomalies using seismographs, which are instruments that pick up earthquake signals and record the ground's motion. When earthquakes happen, they send out ripples or waves through the Earth. These waves travel through the Earth's layers, but if they hit something unusual like an ancient piece of a tectonic plate hidden in the mantle, the waves get disrupted. It's like hitting a bump on a smooth road. It messes with the ride. Using regular seismometers to look for anomalies is fine, and it can totally help us find clues about the Earth's past. But if scientists want to use this method to get pictures of what's really going on beneath the surface, it gets a lot trickier. Not only do the images come out in low resolution, but the process also becomes insanely expensive. So recently, experts just uncovered a cutting-edge technique that could completely change the way we look at the Earth's depths. Kind of like an ultrasound, scientists can now actually see what's happening miles beneath our feet. More specifically, in a region between the Earth's brittle crust and the mantle underneath, known as the MOHO. This new method is called Distributed Acoustic Sensing, or DAS. It uses fiber optic cables, the same ones that give us high-speed internet, as earthquake sensors. Here's how it works. Laser beams are sent through the cables, and when the ground moves, whether from an earthquake, traffic, or other vibrations, the shaking changes how the laser light bounces around inside the cables. The cool part is that we can now measure these changes all along the length of the cable, so the cable ends up acting like hundreds of tiny earthquake detectors spread out over a huge area. This new tech can tell us things like whether major faults go all the way into the mantle, how ancient and modern processes have shaped the continents, and how strong the deep crust is in certain areas. In other words, DAS could be a game-changing instrument to help us uncover new clues about hidden and ancient tectonic plates.
Now see here, astronomers have recently discovered a neutron star, also known as a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe. And it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 12 miles wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of 2 suns and squeezing it into a sphere about the size of a city. A single teaspoon of neutron star material would weigh around 10 million tons. That's the same as the combined weight of 85,000 blue whales. Such an extraordinary density is what gives neutron stars their immensely powerful gravitational fields. When matter falls onto a neutron star, it accelerates to speeds of millions of miles per hour before slamming into the surface. The energy release from such impacts is truly astonishing. Now, despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Now, normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like a neutron gnagi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going any deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penny pasta. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system located in a dense star cluster. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second, but a minute, it'll be over 42,000 revolutions per minute. At the same time, the newbie ties with another neutron star, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait, we can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system, with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. So, you might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. No, accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star's surface, eventually. It triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than our Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and thus confirmed its extreme rotational speed. But wait, the best part is coming. While neutron stars are already extreme, there's another class of them that takes things to a whole new level – magnetars. Now, magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These fields set them apart from other neutron stars. They can distort atoms in nearby objects, making life impossible anywhere near them. As for the energy density of a magnetar's magnetic field, it's so high that it's 10,000 times greater than the mass density of lead. Magnetars also produce bursts of X-rays and gamma rays that are so powerful they can temporarily outshine entire galaxies. These bursts are often triggered by star quakes, violent shifts in the magnetar's crust caused by their own magnetic fields. For example, a gamma-ray burst from a magnetar in 2004 was so strong that it disrupted Earth's ionosphere. It hit Earth, and it was so intense that several satellites picked it up. The SWIFT satellite, built specifically to detect gamma-ray bursts from across the universe, didn't just detect the blast, it got hit with so much energy that its sensors got completely overloaded. And SWIFT wasn't even facing the burst. The energy was so strong it passed through the spacecraft and still overwhelmed its cameras. If a magnetar was located as close to Earth as the Moon, its magnetic field would erase all credit card data on the planet by wiping the magnetic stripes clean. Whoa, that's the level of power we're dealing with here. Magnetars are extremely active, but for a relatively short time. Their intense magnetic fields decay after about 10,000 years. After that, they stop emitting strong X-rays and gamma rays. Astronomers think that there are at least 30 million inactive magnetars in the Milky Way galaxy alone. These silent cosmic relics are scattered all over the galaxy. Neutron stars and magnetars serve as laboratories for extreme physics. They allow astronomers to have insights into the behavior of certain matter under conditions you can never replicate on Earth. The incredible density of these objects helps scientists figure out what happens when protons and electrons get compressed together to form neutrons. This creates states of matter that don't exist anywhere else in the universe. These violent explosions on neutron stars and magnetars also play a critical role in the formation of heavy elements like gold and platinum. These elements get scattered all over the universe during these energetic events, eventually becoming parts of planets and stars and you and me. Oh, by the way, NASA's NICER instrument has played the key role in uncovering the mysteries of neutron stars. Its ability to detect X-rays with high precision allowed astronomers to study the rapid spin of the neutron star we've been talking about and the thermonuclear bursts that occur on its surface. So, what could be nicer than that? So, archaeologists have uncovered an entire block of Pompeii, and it looks like it all belonged to one uber-wealthy individual. They had a huge private residence, a laundry, a bakery, and a large private bath complex where they literally bathed in luxury. Scientists think it could be the largest ever found there, complete with 3 rooms with different temperatures, exquisite artwork, and a huge plunge pool. It was lying beneath layers of volcanic rock and ash for 2,000 years, but it's so well preserved that it feels like the people had only left a minute ago. The bathhouse was in a residential and commercial block known as Region 9 in the city center. It could fit up to 30 people at a time and was a status symbol used to impress visitors. Only a few houses in Pompeii had a private bath complex, so it was something for the wealthiest of the wealthy. The owner may have invited guests to discuss business or even host team-building events, much like a modern-day CEO of some big company. Guests would start in the first room, where they soaked in hot water, then move on to the room where they applied oil to their skin and relaxed in warm water. The final stage was a cold water bath to refresh themselves. It was the largest and most impressive room with red columns and frescoes of athletes. There was also a changing room with a stunning mosaic floor with marble from across the Roman Empire. The complex also had a smaller space painted in pale blue, most likely an ancient Roman shrine used for ritual activities and to conserve sacred objects. It looks like the residence was in the process of renovation. There were tools and building materials in the blue room, like oyster shells on the floor that were supposed to end up on the walls. Another recent discovery from the complex is a large banquet hall with some of the finest frescoes found among the ruins. The bathhouse connected to it, and the guests would enjoy lavish feasts here. In one of the frescoes on the walls of the hall, we can see Apollo and his romantic interest Cassandra, who rejects him. The second fresco shows Prince Paris meeting the beautiful Helen of Troy. Almost the entire floor of the hall is covered by mosaic tiles, over 1 million of them. They probably chose to paint the walls in this room black to hide the traces of soot from all of the lamps. This proves that the hall was lit, and the owners of the residence probably entertain their guests here after sunset. The restorers who are working in the hall need to act quickly to protect new finds and move what they can to a storeroom. They inject a plaster glue to the rear of the frescoes that can't be moved, so they stay in their place on the walls. Archaeologists have been digging at the estate for 2 years. In the summer of 2024, they found the remains of 2 people in the room next to the blue one. They had passed away during the volcanic eruption that buried Pompeii. One was a woman between 35 and 50, and the other was a young man between 15 and 20. Despite the man's age, his bones had signs of wear and tear, so he was most likely of lower status. The woman's bones and teeth were in excellent condition, so she must have been higher up in society, probably the wife of the owner of the house. Scientists found a whole bunch of stuff on the marble top in the room, like glassware, bronze jugs, and pottery. The lady and the young man probably brought them into the room, hoping to wait out the eruption. The guy had some keys near him, and the lady had gold and silver coins and jewelry. The coins are still shiny as new. Pompeii used to be a hub of trade and travel, so these coins must have served them well at one of the many artisan shops, taverns, and about 200 cafes and bars. That's about one place to eat and drink for every 60 residents. They even had fast food shops, something like ancient drive-thrus. Archaeologists dug out one of these with paintings of chicken, duck, and other food that were probably used as a menu. They also found traces of pork, fish, snails, and beef in jars and other containers at the fast food counter. The food was mostly to go and sold in large jars. There were also some back rooms for sit-down eating and drinking. You would only see the residents with a low income at one of such places, as they didn't have kitchens in their homes and relied on cafe food. The wealthy had kitchens in their residences, but they were small, poorly lit rooms, usually tucked away at the back of the house. Most of the time, the only thing inside was a big brick hearth. Some richer families had a small oven built into the corner, kind of like a pizza oven. The only other things in the kitchen were a water basin for cooking and washing dishes, and maybe some wooden tables for preparing food. Romans didn't have fancy kitchen tools like we do today, but they had everything they needed. They used bronze or iron frying pans, deep cooking pots, and small portable ovens to bake bread. Instead of plates, they served food on big round platters. Lunch was a small meal, usually just some meat or fish, fruit, and maybe some drinks. It was quick and not fancy, so people didn't invite guests to eat with them. Since it got super hot in Pompeii, people took a nap after lunch. Later, in the afternoon, they went to the public or private baths, where they would relax, swim, and chat with friends for hours. Afterward, they had their main meal, which was bigger and sometimes included guests. The food was pretty simple, but tasty. Most meals were boiled, smoked, fried, or baked, then flavored with a starchy thickener or fish sauce. The fish sauce was actually so popular that one of the richest families in Pompeii made a fortune from selling it. They even decorated their front hall with a design of garum jars in mosaic. Another big source of wealth in Pompeii was land. Every owner of a big residence had a plot of land where they grow vines or olives or graze sheep. Archaeologists haven't found many of these properties yet because it's hard to know where to look for them. But they did find a burial ground of one well-known Pompeian family in the countryside, next to what they believe was their country house. One of the most exciting things to do for Pompeians with different levels of income was going to the amphitheater to watch big, action-packed shows with gladiators. Their giant stadium is the oldest surviving one of its kind in the Roman world. The shows lasted for days, and crowds came from all over to watch. Fans got so excited that in 59 CE, a huge brawl broke out between people from Pompeii and a nearby town. After that, the authorities shut down the amphitheater for 10 whole years as punishment. Some people in Pompeii even made paintings on the walls about that brawl, bragging about their victory. There were also paintings of the gladiators. Many Pompeians also loved going to the theater to watch plays. The local theater was built in the 2nd century BCE and was later made even bigger and fancier. People watched funny comedies, silly performances called farces, and dramatic plays about ancient myths. Some plays came from Greece, and wall paintings in Pompeii showed that people liked the famous Greek playwright Menander. Next to the big theater, there was a smaller roofed concert hall built around 75 BCE. They used it for musical performances.
A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever ANITA has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. ANITA is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Wissel explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
Scientists have recently discovered Leonardo da Vinci's hidden passages under a medieval castle in Italy. They followed a newly found 15th century sketch by the creator of the Mona Lisa and found one of the unexplored architectural wonders from the age of the Renaissance. Construction of the Sforza Castle started back in 1358, but it was destroyed about a century later during a local crisis. Then, in 1450, Francesco Sforza, the Duke of Milan, decided to rebuild it on the old ruins. After he passed away, his son Ludovico took over and kept improving the castle. He brought in some of the best artists of the time, including Leonardo da Vinci, to decorate its walls. We can still see Leonardo's frescoes today in the Room of Wooden Boards. While he was working at the castle, da Vinci also recorded some historical underground passages hidden beneath the outer wall. The drawing, dated between 1487 and 1490, was found at the Institut de France in Paris. The sketch is highly precise, and it proves that Leonardo was really interested in fortification design and was great at documenting existing structures. Historical records show that Ludovico ordered the building of an underground passageway that led straight to a basilica, where his wife was buried. Ludovico married Beatrice in 1491, and they had a happy but tragically short marriage, as Beatrice passed away while giving birth in 1497. The Duke locked himself away for weeks, grew a beard, and wore only black clothes while he was mourning his beloved wife. The secret tunnel may have stretched over a half a mile and would let Ludovico visit her grave in private. It could have served as an escape route if the castle was ever under siege. The existence of the tunnels remained one of the mysteries of the Renaissance for years, as no one knew for sure they were there. But now, scientists finally uncovered the secret history. They used a combination of ground-penetrating radar and laser scanning to build up an accurate 3D model of all the structures under the castle. They found the tunnels Da Vinci alluded to in his drawings, and it looks like they may have only been a small part of a whole system of historical underground passages. The goal is to create a complete digital twin of the castle that will not only show all the preserved constructions, but also the ancient ones that are no longer visible. They also plan to add augmented reality to the virtual paths to let visitors discover Leonardo da Vinci's hidden passages. Now, we don't know if the genius actually took part in constructing the hidden passages that scientists recently discovered, but we do know about some other Leonardo da Vinci inventions. He created the first satellite-like map in 1502, long before photography or satellites were even a concept. A famous figure in Italy, Cesare Borgia, invited Leonardo to a small town called Imola, near Bologna, to create a highly detailed map for him. Back then, maps were not very precise, as no one had figured out how to show exact distances on a smaller scale. Instead, people spent a lot of time decorating them with dragons, roses, fancy castles, mountain ranges, flowers, and other artistic details. These maps look more like beautiful paintings meant to be displayed, rather than practical tools for navigation. But Cesare Borgia wanted something truly functional, and Leonardo managed to create something revolutionary in the field of cartography. If you compare satellite images of Imola today with Leonardo's map, the similarities are striking. He captured every alley, curve of the streets, roadways, and even the exact sizes of the buildings. And he did it all by hand, using just a pencil, ruler, compass, and several of his own clever inventions. To gather all the necessary data, the genius walked through the streets for weeks using a large wheel that spun as he moved, recording the distance with a cable. Using the magnetic compass, he determined precise directions. He also developed a tool called the bussola, which measured angles inside a circle. With this, he could track the exact turns of each street and the size of the intersections. He figured out the distances between houses and major roads. Then, back at home, he used his notes and calculations to draw the map to scale with incredible precision. In his work, Da Vinci also used a technique developed by Florentine humanist Leon Battista Alberti. He created a mapping method where you could place an entire city inside a circle using polar coordinates. At the center of the city, 8 straight lines met, representing the main directions of a compass. Leonardo used this system to divide the town into 8 sections. He didn't overlook even the smallest buildings, which made his map one of the most advanced of its time. The Italian genius had a big dream to build a machine that could let people fly. He studied how birds, bats, and kites moved through the air and designed a special flying machine. He believed that if he could copy their movements, humans might be able to soar like them. Da Vinci's design looked a lot like a bat, with 2 large pointed wings that stretched over 33 feet wide. He planned to build the frame from lightweight pine wood and cover it with raw silk to make it strong but not too heavy. The person flying it would lie on their stomach on a wooden board in the center. To make the wings flap, the pilot had to pedal a crank with their feet, which was connected to a system of rods and pulleys. There was also a hand crank for extra power and even a headpiece to help steer. As the person moved their hands and feet, the wings would flap and twist, just like a bird's. But there was one big problem. Humans aren't strong enough to make the machine lift off the ground. Even though it might have worked once in the air, there was no way for a person to get it flying on their own. Leonardo probably realized this, but his amazing idea still inspired flying machines that came centuries later. Da Vinci was way ahead of his time with many of his inventions, but his idea for a humanoid robot was especially futuristic. He was working under the patronage of the Sforza family, the one that had those ancient tunnels of Italy built. The genius designed a mechanical knight that could move its arms, turn its neck, and even open and close its mouth. Da Vinci had good knowledge of anatomy and the mechanics of body movements that helped him. His unusual creation used an external system of cables. A hand crank set it in motion, and there was also an internal gear-driven mechanism. About 450 years later, Da Vinci's detailed sketches of the robotic knight were rediscovered in the 1950s. Several researchers tried to recreate the robot from those sketches. In 2002, a roboticist who developed systems for NASA and Lockheed Martin took inspiration from the old notes and built a functioning model of Da Vinci's robotic knight. Another design Leonardo created for Duke Sforza was a special kind of bridge that could be taken apart and carried easily. It was made for defense forces who needed to cross rivers or moats while traveling. This bridge would swing across the water and land on the other side. It had wheels and used a rope and pulley system, so it could be set up quickly and packed away just as fast. To keep it steady, it even had a special weight to help balance it. Leonardo wrote in his notes that the bridge was light yet strong, and he designed several bridges like this for the Duke. One of his other designs was a bridge that could be built very quickly, and the defense forces would move across multiple rivers. As scientists continue to study Leonardo da Vinci's hidden passages, they reveal new chapters in human history. Who knows what other unexplored architectural structures they will find?
In 2020, strange signals from deep beneath Antarctica sent shockwaves through the news. Within days, headlines exploded. NASA had found a parallel universe where time runs in reverse. But what really happened? And what did scientists actually detect? Well, this story is a case of madness, misunderstood experiments, and the human need to believe in mystery. Even today, every few months, someone reposts a headline screaming that NASA found a parallel universe in Antarctica. A universe where time flows backwards, and people believe it. But no, NASA didn't find a mirror world under the South Pole, or some sort of a backwards reality where people age in reverse or speak in rewound sentences. They did find something curious, though. Here's what actually went down. Scientists were flying a strange-looking instrument over Antarctica called ANITA, short for Antarctic Impulsive Transient Antenna. ANITA is a machine that floats over Antarctica. Basically, a giant balloon with antennas. It listens for tiny space particles called neutrinos. Neutrinos are super small and ghost-like. They have almost no weight and go through stuff like it's not even there, even entire planets. Usually, these neutrinos come from space and rain on Earth from above. Most neutrinos, the common low-energy ones, just fly right through the Earth like it's air. They're like tiny bugs flying through a chain-link fence. There are some very high-energy neutrinos, though. They're super rare and they interact a bit more often with matter, and they can get blocked. If high-energy neutrinos hit something dense enough, like the rock and metal inside Earth, they might finally bump into a particle and get absorbed. That's more like fast tennis balls that hit the fence once in a while. Low-energy neutrinos, which are everywhere and pretty harmless, are pretty undetectable. But these high-energy guys are exactly what ANITA can detect. When they slam into ice, they send some radio waves that are easy to listen to. This faint radio signal is called the Askaryan effect. And yep, that's exactly why ANITA is flying over Antarctica. That's because the ice is pure, dry, and quiet. It's perfect for catching those rare signals. So, what did ANITA detect?
It detected something rising up from below the ice, like a high-energy neutrino coming from the Earth. What? Okay, let's think logically. Maybe it started somewhere in the north, traveled all the way through the Earth, and popped out the other side. Still, that's super weird. That's not supposed to happen. Neutrinos with that much energy should have been stopped inside the planet. Like we said, get absorbed. So, scientists caught a little bit of a brain bug. That shouldn't be possible with our current physics, unless something we don't understand is going on. And when you're faced with something bizarre, you explore all options, even the wildest ones. The nightmare began. A group of researchers published a paper suggesting that this strange signal might make sense in a CPT symmetric universe. CPT stands for charge, parity, and time. These are basically three ways to flip the universe. Charge means swap all particles to their opposites. For example, swap electrons, the guys with the negative charge, with positrons, their antimatter twins with the positive charge. Parity means mirror the universe, literally like looking at it through the mirror. Left becomes right and right becomes left. And time, of course, means run time backward, like rewinding a video. Now, there's a big rule in physics called CPT symmetry. It says that if you change all three of those things at once, the laws of physics should still work the same. This is kind of insane, but if you took the entire universe and swapped matter with antimatter, mirrored it, and reversed time, it would still follow the same physics. Why is that? Well, in our universe, an electron bumps into a positron, and they annihilate into photons. Cool! Now take that, mirror everything, and what do you get? Well, photons spontaneously turn into a positron and an electron, but mirrored and reversed. It's still the same physics, even if it's backwards. The equations still check out, so nature thinks this is valid. So here came the crazy part. Some physicists thought, what if the Big Bang created two universes? One is ours, made of normal matter going forward in time. The other is a mirror twin, made of antimatter, going backward in time from our perspective. This doesn't mean that someone in the other universe feels time going backward. To them, time flows forward, just like it does for us. But from our point of view, they're moving from our future toward our past. And vice versa. To them, we're weirdos who move backwards. And if both universes are exact CPT mirror images of each other, that would mean same physics, same rules, just symmetrical. Same rules, just symmetrical. This isn't some crazy sci-fi theory, even if it sounds like it. It helps explain weird physics mysteries. For example, why there's so much matter in our universe but not much antimatter, even though they were supposed to be created in equal proportions. Or why the universe is so symmetrical and balanced in some strange ways. So, coming back to the neutrinos, some scientists suggested that maybe those upward flying particles could be coming from that CPT mirror universe, poking through into ours, like a crack between two symmetrical realities. And if you look at it like that, this is quite a wild take. It's speculative, it's not proven. It's more of a cool thought, but the media immediately blew up. They ran a piece with the headline that said we found proof of a parallel universe going backwards in time in Antarctica. And all the other big tabloids picked it up. They made it sound like NASA had actually found a parallel universe. Time travel is real. Multiverse is confirmed. Meanwhile, people who worked directly on Anita immediately caught brain damage. They tried to jump in to say that's not what happened at all. They explained that the signals were unusual, yes, but there were plenty of normal explanations that didn't require rewriting the laws of physics. It could even be just an experimental error. Maybe an unusual particle behavior or gaps in how we model neutrino interactions. Of course, no one listens to experts about what experts discovered. And once an idea like that hits social media, it becomes nearly impossible to put back in the box. But that also doesn't mean that the multiverse definitely isn't real. Far from it. Physicists are still exploring the concept and assume that some of those potential universes, if they exist, could have different laws of physics. One idea, called the many worlds theory, comes from quantum physics. It says that every time something can happen in more than one way, like a particle moving or a decision being made, all those possibilities actually happen, but in separate universes. So there could be endless versions of reality, each slightly different, branching off from every event. Maybe in one universe, dinosaurs never went extinct. Maybe in another, you never sent that embarrassing text. Another theory is called the bubble universe theory. After the Big Bang, the universe expanded incredibly fast in a process called inflation. Some scientists think that inflation never fully stopped and is still happening in some regions. That would mean new bubble universes are constantly forming, each with its own version of physics. Our universe would just be one bubble in a giant cosmic sea of others. The third idea is about shadow matter. Dark matter is invisible, but its gravity affects the universe. Some scientists think it could be made of particles similar to the ones that make up regular matter, but they're just hidden from us. This mirror, or shadow matter, could form entire invisible galaxies and even life, all existing right alongside us. Maybe we just can't detect it in any way, except through gravity, for now. But in physics, all of those are just theories, mathematical possibilities. We have no direct evidence that it's real. If we ever find one, though, let's now hope it won't be the boy who cried wolf scenario.
What do you think is one of the most dangerous animals in the world? It's not a venomous snake or a formidable tiger, not a ferocious grizzly bear or a giant crocodile. An extremely dangerous creature that can destroy entire species of animals and can cause ecological imbalance around the world is the cane toad. It doesn't look scary and aggressive. It won't attack you or any predatory animal. It spends its time among grass and swamps, hunts insects and croaks. It has many enemies among predators, herons, lizards, and others. And look, the crocodile is swimming up to the toad and grabs it with its powerful jaws. Lunch is ready. But watch what happens next. The crocodile feels very bad. It loses its strength and lies on the grass, not breathing. Call it terminal indigestion. The fact is that the cane toad is a highly poisonous amphibian. It has parotid glands between the shoulders from which it secretes a dangerous toxin. As soon as it gets into the stomach of any animal, it causes irreversible reactions in the whole organism. Animals that have eaten cane toads rarely survive. And now imagine there are 1 million toads like that, and each of them is an attractive lunch for predators. This creature is native to South and Central America, but became most famous after it caused an environmental disaster in Australia. It all started in 1935 when people brought cane toads to fight the cane beetle. These insects were spoiling sugarcane crops in the northern part of the country. Farmers thought the imported toads would quickly get rid of the pests, but far from getting help, Australia received even more damage. The first problem was that toads didn't hunt bugs. Well, that would have been nice to know beforehand. Insects lived on the tall stalks of reeds, and toads couldn't jump as high, so toads would feed on other insects and multiply rapidly. Initially, about 100 reed toads were brought. Farmers managed to breed more than 2,000 of these animals and release them into the fields. The amphibian population grew to 200 million in less than 85 years. They flooded Australia and caused a decrease in the population of those predatory animals that fed on them. Unfortunately, the local fauna didn't manage to develop immunity to the toad poison. The invasive toads would wander all over the northern part of the continent, spreading at a speed of 30 miles per hour and causing damage to all the biological environments they came across. Locals said they had witnessed birds falling from the sky after eating toads. These jumping animals are dangerous for those who eat and touch them. Any animal that licks or bites a toad will immediately receive a measure of poison hazardous to their health. The endurance of toads escalates the problem. They can withstand nearly any weather conditions and can breed anywhere. You can hear them croaking in tropical forests, coastal thickets, and even among dunes. They deal with cold temperatures and heat and eat everything in their path. They're not picky when it comes to food. Amphibians feed on live insects, carrion, and waste. But the most crucial problem is the speed of their reproduction. Female cane toads lay from 8 to 30,000 eggs twice a year. Within 3 days, tiny tadpoles hatch from the eggs. They swim in the water for 20 weeks, then become toads. Their life expectancy is from 5 to 10 years in the wild. Bad weather conditions, predators, drought, and anything else can't stop them. People don't know what to do with them either. The only chance to save other animals is to teach them not to eat toads. Scientists cook sausages from cane toads with a small concentration of poison inside. They gave this food to monitor lizards, freshwater crocodiles, and other predators so they could recognize the taste of the toad. Animals were slightly poisoned by the toad sausages, and remember that anything with this smell was dangerous. Scientists hope they won't approach the toads after smelling them. Amphibians have destroyed most of the biodiversity in the northern part of the country, and now they're rapidly moving to Western Australia. Scientists hope their plan saves animals, but what to do next? Perhaps nature can offer a solution to the problem. Some predatory animals may become immune to toad toxins, but it's unknown when this will happen. Invasive toads are quite a severe problem for ecology, but they look harmless. And how about invasive pythons? In the Everglades in Florida, Burmese pythons threaten the local wildlife. Giant crawling monsters have become the dominant species, displacing their alligator enemies from the swamps. Pythons hunt rabbits, possums, and other animals, decreasing their population by 99%. Of course, there are not as many pythons as toads, and people can get rid of them. But the problem is that they are exceptionally good at hiding. Even professional wildlife experts can't find them in the swamps and jungles. These pythons are also excellent hunters. They hide, wait, and attack, which makes them some of the most dangerous invasive creatures in the world. But fortunately, they don't attack people. Feral hogs are some of the most aggressive invasive species on Earth. They have razor-sharp teeth and mighty tusks. They're not afraid of anything and will attack even a human. These big, fast animals eat acorns, chestnuts, turtle eggs, turkey and quail eggs, trample plants, and strike terror into all creatures in the area. They can cause $1.5 billion in damage annually in 47 states. Imported in the U.S. several centuries ago, feral hogs have recently experienced a fertility splash. Local biologists and farmers are trying to solve the problem, but at the moment, it's pretty challenging to control the feral hog population. This tiny beetle seems harmless, but can cause orange juice to disappear in the U.S. This is the Asian citrus psyllid that loves to eat orange fruit. This insect contains bacteria that infects citrus trees and slowly destroys them. After getting infected, tree roots deform, oranges fall to the ground earlier than they're supposed to, and the tree slowly loses vital energy. The Asian citrus psyllid spreads in Florida, where about 80% of the country's orange juice is produced. Also, this parasite is found in Georgia, Texas, Louisiana, and California, the states where many lemons grow. So we've seen invasive amphibians, reptiles, mammals, and insects. What about invasive birds? The European starling is a cute little bird, but it ceases to be so as soon as it joins a giant flock. Starlings gather in groups of hundreds and thousands, resembling massive black clouds. They fly to cities, villages, and harvest fields in search of food. Birds eat cattle feed and thus create a lot of problems for farmers. This invasive insect doesn't threaten other animal species, doesn't spoil crops and trees, doesn't bite, and doesn't transport any infection. But its main problem is the unpleasant smell that it emits. There are so many brown marmorated stink bugs in the US that, most likely, some of them live in your house. If you've ever seen it, you probably remember that stinky smell. Thanks to this fragrance, stink bugs have almost no enemies, at least in America. But in China, their populations are controlled by wasps that use the back of bugs to lay eggs. There are no such wasps in the States, so stink bugs breed freely here. Now, let's talk about one of the most invasive plants in the world. This is giant hogweed. It secretes a poison that is activated when exposed to sunlight. The toxin can burn skin and destroy trees and plants growing around giant hogweed. From the outside, it may seem like a beautiful plant. It has a tall 15-foot stem with a beautiful white flower. But this plant gets rid of other vegetation around it. Giant hogweed releases its seeds, and a light breeze spreads them for miles. When new plants grow, they destroy any other plants living nearby. The problem is that giant hogweed has no enemies. Insect pests can't eat it because of its poison. Animals also avoid it. Well, maybe nature will create some bugs that will eat its leaves and thus restore the balance. Hey, look at this rock. At first sight, it looks like a regular boring rock, the likes of which you can see when walking along the beach. Its color doesn't stand out, and its weight is pretty regular, around 4 pounds. But everything changes when you learn that this rock was born on Mars, traveled all the way to Earth, and ended up in Antarctica. Now the story sounds much more fascinating. So let's find out the details. Researcher Roberta Score, who worked on the ANSMET project, which stands for Antarctic Search for Meteorites, of the Denver Antarctic Program, found this meteorite in 1984. If you want to decipher the name of the space traveler, I can help you. It comes from the place where the scientists spotted it, the Allen Hills of Antarctica, hence ALH. And then we've got the year of the discovery and the number of the sample. If you think that Roberta picked up the rock and exclaimed something like, "Woohoo, I'm holding a chunk of Mars," I'll have to disappoint you. At the very beginning, it was totally unclear where the meteorite came from. And one thing confused researchers even more. The meteor was very different from other meteorite groups found on our planet. Okay, but then how did they finally figure out it was a visitor from Mars? All thanks to traces of gas similar to those that make up the atmosphere of the red planet. We learned about its composition thanks to the brave Viking lander that carried out the necessary analysis in situ in 1976. Anyway, back to our rocky discovery. It's actually very special, and not only because the rock arrived from far, far away. Among those several thousand meteorites found on Earth, just around 100 have likely come from Mars. And even so, our guy is different from them and seems to be part of a separate group. So let's go into the past and follow the life story of this cosmic traveler. It most likely formed around 4 billion years ago on its home red planet. One day, which wasn't very different from others, turned out to be life-changing for this peaceful rock. A meteorite impact catapulted into space, and it started its own journey as a small asteroid. At that time, it was way larger than at the moment of discovery on Earth. At one point, ALH got close to Earth and, who knows, probably decided to explore something. That's how, 13,000 years ago, it ended its space journey by colliding with our planet. At the moment, this Martian fragment is the oldest we've got. But at first, it wasn't all that popular. Only in 1996 did it become way more famous after a groundbreaking discovery. You see, some NASA researchers started wondering, well, the fragment is obviously very old. But then, could it have recorded any traces of life that could have been thriving on Mars at the time ALH formed on the red planet? And guess what? Those scientists turned out to be right. They detected traces of very fine magnetite particles. Those were completely similar in structure and chemical composition to the particles we have on Earth. They're called magnetofossils, and magnetotactic bacteria produce them. So it might mean that, at one point, there were some forms of life on Mars. In April 2020, scientists from the Japanese Space Agency made another discovery. They detected nitrogen containing organic material of Martian origin in our meteorite. So, who knows what new astounding secrets further examination of the meteorite might reveal? At the moment, though, all you can do is travel to Antarctica and find more of them. The thing is, this place is great for meteorite hunting. Surprisingly, we have found nearly 50,000 meteorites in Antarctica, and hundreds of thousands are still waiting to be discovered. Each of these space rocks can tell us a story of the evolution of the solar system. For example, the very first lunar rock found on the icy deserted continent proved that chunks of space objects larger than asteroids can also end up on Earth. So, let's say you got inspired and decided to go meteorite hunting all the way to Antarctica. Well, get ready for some serious challenges. Despite their potential abundance, finding space rocks isn't as easy as it might seem. You'll have to visit remote areas, and there's still no guarantee that you'll be able to spot a meteorite. And that's actually a huge problem. Meteorites are vanishing from sight. Currently, scientists find about 1,000 meteorites in Antarctica each year. But according to a new study, about 5,000 more get hidden out of sight every year. The culprit is warming temperatures. Worried scientists created a model that could help them figure out where those meteorites might surface. This model was quite complicated, taking into consideration snow cover, surface temperature, the speed at which ice flows, and even the steepness of the terrain. After that, they ran simulations under various warming scenarios. It turned out that meteorites indeed sank out of sight as temperatures rose. To say that the researchers were upset is obvious. They didn't expect that climate change would affect their work so much. Even though those areas are below freezing, people still managed to ruin a crucial archive of the solar system. But let's get back to your meteorite hunt. If you want your chances to find one to be higher, travel to the base of mountains or outcrops where ice, which usually flows to the lower ground, is forced to move upward. But make sure to take your windbreaker with you. In those places, powerful winds brush away snow, exposing bright, vivid blue ice. Instead of melting, this ancient ice can change directly into water vapor, and it helps expose meteorites that would otherwise remain hidden. You need to hurry though. Meteorites at the surface disappear quickly. Even when temperatures are well below freezing, the rocks can still absorb some of the sun's heat and melt the ice. It's like they're creating underground, or shall I say under ice, tunnels for themselves, sinking and hiding from sight. Sometime later, refreezing closes the entrance to those tunnels, effectively trapping meteorites inside, tucked out of sight. Now, scientists admit it's very tricky to find working methods to spot meteorites. And if we don't hurry and develop such methods, we might lose between 80,000 and 250,000 space rocks in total. No wonder scientists are on a mission to find more meteorites. They're focusing on meteorite stranding zones. Those are places where meteorites often gather on the surface because of specific features of geology, ice flow, and climate conditions. As you already know, you can find meteorites on blue ice without snow cover. This makes meteorites easy to spot. But finding such hotspots is often pure luck. Or you gotta sit day and night, scouring maps and satellite images in attempts to spot blue ice zones near research stations. Let me introduce Veronika Tolinov, a glaciologist, and her team. They've taken things to the next level by developing a smart Antarctic-wide map. To do it, they've used machine learning and satellite data from NASA, the Canadian Space Agency, and others. This map highlights areas where meteorites might be hiding based on past finds and all kinds of climate and ice data. Apparently, the best places to find meteorites are along the edges of the continent and near mountains with blue ice. Unfortunately, it's not just the blue ice that matters. The temperature and speed of the ice flow are also super important. For example, if the ice flows too quickly, meteorites get swept away before they can accumulate. So, if you want to find a meteorite, you have to wait for very precise conditions. The surface temperature has to stay below 16 degrees Fahrenheit almost all the time. Otherwise, meteorites sink. You can start with the Allen Hills region. Yup, that's where our ALH friend was discovered. This area is kind of a meteorite gold mine with more than 1,000 finds. But there are even more promising places, like the Fimbulheimen Mountains, and no one has searched there yet. You might be the first. In any case, with this new map, researchers developed a where-to-go index that ranks the best meteorite hunting spots, making future field trips much more targeted. And with plenty of blue ice regions still unexplored, there are tons of meteorites just waiting to be found. So, what are you waiting for? A mega drought might hit Australia soon, and this isn't just about a couple of dry seasons. We're talking about 20 years of little or no rain. While Australia could be facing the longest and most devastating drought since official records began, the rest of the world might struggle to buy bread, flour, or cereals. Energy prices are likely to spike globally, and neighboring countries like New Zealand, Indonesia, and Malaysia must be prepared to receive Australians directly affected by the lack of water. To truly understand how severe this situation could become, we should first examine past disasters. First off, Australia is no stranger to droughts, and this phenomenon can happen across their entire territory. From 2017 to 2019, the southeast part of the country went through what they call the tinderbox drought. This was a severe bone-dry event where the cooler months saw only about half the usual rainfall. Parts of Australia became so dry that wildfires were a constant threat. Crops failed, and water was scarce. This drought was also thought to have contributed to the Black Summer fire disaster. By the end of 2019, bushfires were raging across the country on a scale never seen before, with people describing them as rivers of lava flowing down from treetops. The losses were staggering. The tourist industry alone took a hit of $2.8 billion, and over 7,000 jobs disappeared as a result of this difficult period. The tinderbox drought was a big reminder of what Australia might face in the future. That's why it's so important to understand what happened in the past to get a full picture of a possible 20-year mega drought. But there is one problem. Even though droughts are relatively common in Australia, the rainfall data available until today isn't enough for researchers to predict the future, and our records only go back to around 1900. So experts decided to study tree rings to uncover missing environmental data. If you look at a tree stump, you'll notice concentric rings on its surface. As trees grow, they form new rings, and the thickness of these rings depends on how much water they get. During a mega drought, the rings appear thinner because the trees don't have much water. Unfortunately, these natural records usually only go back a few hundred years, and it only tells us about specific local conditions, not the situation across all of Australia. So, experts turn to computer models to simulate how Earth's climate changed from the year 850 to 2000. This approach helped them to paint a picture of when mega-droughts might have occurred in Australia and how to predict what might happen in the future. But what they were really interested in was whether the human factor might be making this scenario worse over the years and if we are somehow intensifying these dry periods. So, are we to blame for these mega-droughts? The short answer is, we're not sure yet. On one hand, dry periods in Australia do seem to last longer than they did before factories and machines became common. On the other hand, they don't seem to be getting more intense or happening more often than before industrial times. This means a drought lasting 20 years might not be directly linked to human activities. Actually, this kind of phenomenon is just a normal part of how rainfall changes in Australia over time. This is backed up by evidence from ice cores, which suggests that a 39-year drought hit eastern Australia around 800 years ago. What makes it all so fascinating is that there isn't just one cause for this phenomenon. I mean, there is no single mechanism that explains all cases of megadroughts. It happens because the right combination of ocean and atmospheric conditions come together, and you end up with a drought. And just by random chance, you might have periods where there are 100-year-long droughts. Despite what many people think, mega-droughts are not geographically isolated. They have occurred on every continent except Antarctica over the past 2,000 years, and are often linked to natural events. For instance, mega-droughts in North America and Southwest South America were driven by El Niño, where the Pacific Ocean near the equator gets warmer than usual disturbing normal weather patterns. They are not rare events either. In fact, the U.S. Southwest has been experiencing a mega drought since 2000. It's being considered the driest period in 1,200 years for the region. Major reservoirs like Lake Mead and Lake Powell are at low levels. Heat waves are hitting cities like Phoenix and Las Vegas harder than ever. And wildfires are happening more frequently as the land gets drier. Now, let's think about the future. Even though we have a very recent and concrete example from the U.S., research can't exactly predict how a 20-year megadrought would play out in Australia. Usually, such events show up mainly as reduced rainfall and snowfall. But in most areas, the increase in drought risk will be caused by a warmer, more arid atmosphere. So the ground will probably look parched and cracked, rivers and lakes will likely shrink, and the sky will be relentlessly clear and blue, with barely a cloud in sight. Farmers might struggle to grow crops, making grocery prices rise worldwide. Things like bread, flour, and cereals may become scarcer, as Australia supplies about 13% of global wheat exports. Coal mines might be affected, as they depend on water for extraction, washing, and processing. That might drive up power costs for industries around the world, which could be passed on to consumers, impacting global growth and inflation. As cities might face water shortages, Australians will likely find new ways to conserve every drop or maybe move to New Zealand or Southeast Asia. Now, you're probably thinking, when is this big event going to happen? Honestly, it's really hard to predict exactly. Megadroughts can happen every 150 to 1,000 years, but experts think Australia should be ready for one to happen in the next 10 years or so. And this possibly should be taken seriously. This phenomenon has been known to contribute to the collapse of entire civilizations. Take the Akkadians of Mesopotamia, who built the world's first empire more than 4,000 years ago. Studies of moisture at the ruins of Akkadian cities suggest that they experienced a massive drought lasting 300 years, and this may have led to their collapse. A similar thing happened to the Assyrian Empire, which existed over 2,700 years ago, in what is now northern Iraq. For years, it was a real mystery why they left their capital of Nineveh and never returned. But recent studies of a stalagmite in the Cunaba cave revealed that the rise and fall of the empire coincided with a wet period followed by a 125-year-long mega-drought. Because they were very dependent on seasonal rain for agriculture, this dry period made their life much harder. Even though experts now believe they probably left because of the dryness, the question of where they went is still a mystery. So, yep, mega-droughts may have played a role in the collapse of great civilizations in the past. But on the positive side, we've come a long way since then, and recent climate technologies can help us prepare for events like this. Now that we know a 20-year megadrought is very much possible and might happen soon, Australia has some time to get ready for it. Developing strong water management plans to mitigate the severe impacts of a megadrought is more than necessary, and it's also important to create community support networks to provide emotional and financial support to people, particularly farmers, who are more affected directly by this event. If initiatives like these emerge in the coming years, those 20 years of drought could be less intense than most people might expect.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand. along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritius broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year, because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
See how the Antarctic Peninsula looks just like South America, but upside down? This isn't just a coincidence. It's the ghost of a 30-million-year-old breakup. These continents were once connected, but their divorce gave birth to an ocean current so powerful it was capable of completely freezing Antarctica and shaping its landscape. Here's how it went down. Tectonic plates pulled a sneaky move and cracked open a ridiculously narrow passage in the ocean, about only 500 miles wide, forcing 4.5 trillion cubic feet of water to flow inside this geological straw. This was the birth of an ocean current stronger than the Amazon River. This ocean current, called the Antarctic Circumpolar Current, by the way, flows in a circular motion, going clockwise because of the strong winds that blow over there. This circular motion around Antarctica caused erosion, shaping the landmass of the continent into a circle, except for that stubborn peninsula, which is being slowly dragged east like a kid refusing to leave a playground. Wait, South America and Antarctica used to be one? Yep, a long time ago. South America, Australia, and Antarctica were all part of a supercontinent called Gondwana, which also included Africa at some point. Back then, South America and Antarctica used to be basically joined at the hip by a land bridge called the Antarctic Land Bridge, which just so happened to be a lush green forest and also a great dinosaur highway. Yeah, you heard it right. Dinosaurs. A 95-million-year-old dino, whose name I can't pronounce, sorry, was discovered in Australia, and scientists found out it had actually been a distant cousin of Argentina's Sarmientosaurus. Same jaw, same chisel teeth, same everything. These guys were like identical twins, separated by an ocean. How? Because back then, Antarctica wasn't a frozen wasteland. It was a temperate rainforest, like Oregon, making it a pretty nice travel route for a dino family. But the land bridge wasn't just for dinosaurs. About 40 million years ago, the ancestors of Australia's marsupials waddled to the land down under all the way from South America, taking the Antarctica route, another proof that these continents used to be connected. Things remained somewhat peaceful for the dinos and the marsupials until Earth's ground started moving. This is what a German scientist called the continental drift theory, back in 1912. Our German friend here basically looked at the coast of South America and went, "Hey, this looks like it could fit into the coast of Africa." Like a scientific Sherlock Holmes, he noticed what others had overlooked for centuries. The continents were clearly pieces of a larger puzzle. And he was right. Here's the deal. Planet Earth is made of many layers of rocks and metals, like a cosmic onion. The outermost layer, the lithosphere, is divided into pretty solid tectonic plates that move atop a layer of softer, somewhat molten rocks, like slippery ice. This is why the plates move. In fact, they've been rearranging Earth's face for billions of years, with supercontinents forming and breaking apart in cycles, like a slow-motion game of bumper cars. This movement might be pretty slow since most tectonic plates only move 0 to 3.9 inches every year, except for the Nazca plate, racing ahead at 7.8 inches, about as fast as your hair grows. But don't let their snail's pace fool you. These shifting slabs are the ultimate planet shapers. Their slow dance gives us everything from earthquakes that build mountains like the Himalayas, to rifts that birth oceans like the Atlantic. All because the oceanic crust is dense and sinks like a stone, while continental crust floats like a cork. It's this density difference that explains why continents exist at all. Without it, Earth would be completely covered by shallow seas. This slow-motion planetary renovation project is exactly what tore South America and Antarctica apart 30 million years ago. The plates under these continents started to drift apart in a process called crustal extension. It's like the lithosphere was pizza dough being slowly stretched until it thins and splits. As the crust stretched, it became thinner and weaker, eventually cracking like the surface of a drying lake bed. This whole thing gave birth to a new tectonic plate, the Scotia Plate, that emerged between South America and Antarctica, like a geological divorce lawyer. For a while, parts of this plate stayed above water as the last gasp of the Antarctic land bridge. It was Earth's version of that one thread still connecting your hoodie after the zipper breaks. These final connections might have persisted as chains of islands, but just like that fraying hoodie, the connection couldn't last forever. Eventually, this small but mighty plate became the final nail in the coffin of the land bridge connecting the two continents. Just like all the tectonic plates, this one was also on the move. As it expanded eastward, it opened a new passage of water called the Drake Passage, slowly covering the Antarctic land bridge with ocean water. The process was like pulling open elevator doors. At first, just a crack, then wider and wider until the connection was completely broken. This geographical divorce had chilling consequences. The new Drake Passage allowed the Antarctic circumpolar current to form, creating an endless loop of cold water that isolated Antarctica, shaped its land, and even cooled the entire planet. This current acts like a wall around Antarctica, blocking warm water and invasive species while regulating global climate. Eventually, Antarctica turned into an icebox that is 98% covered in ice sheets, and that holds about 61% of Earth's fresh water. Nowadays, this continent holds the title of the windiest, driest, and iciest place on Earth. It's a frozen desert where temperatures plunge below -128.6 degrees Fahrenheit, cold enough to freeze your breath mid-air. A layer of ice there can be more than a mile thick, and it expands even further in winter to cover an area larger than the continental United States. Today, if you want to travel to Antarctica, the quickest sea route is through the Drake Passage, a 500-mile wide body of water that is narrow enough for the winds to scream across thousands of miles. transforming into monstrous waves that can tower up to 49 feet, though calm days create waves only 13 to 16 feet high. Still twice as tall as Atlantic waves, mind you. This is probably why sailors call this stretch of ocean the Drake Shake. But tectonic movement isn't just about shifting continents. It's Earth's ultimate life support system. You see, about half of our planet's heat comes from radioactive decay in the core. Thanks, uranium-235. Something like nature's nuclear reactor. This heat is behind everything from volcanoes to the very plate motion that once connected Antarctica to South America. And it only comes out of the core because of tectonic movement. Without this internal heat engine, Earth would be just like Mars. When the plates move and release heat, they also release CO2 gases into the atmosphere, regulating the temperature of our planet. And when the plates move underwater, they take a lot of this CO2 back to Earth's interior, recycling all this gas. This is why the plates can change our air, climate, and even the evolution of life itself just by moving around. But billions of years ago, these plates were not moving around. Back then, it was like Earth was wearing a solid ceramic shell with many cracks. But even without tectonic movement, the heat managed to escape through these cracks in a process called stagnant lid tectonics, kickstarting all life on Earth. And no, tectonic movement is not a thing of the past. Earthquakes are the living proof that it is not just happening today, but might repeat again on a more dramatic scale in the future. You see, to form supercontinents like Pangaea, smaller megacontinents have to dive beneath another. And scientists predict that a similar process might create a new supercontinent called Pangaea Proxima in 250 million years. By then, humans might be extinct or living on Mars, but Earth's tectonic dance will continue, even without us. Not bad for something that moves more slowly than a traffic jam. Turns out, Antarctica and South America used to be BFFs before all that tectonic drama split them up, like a messy breakup that literally froze one of them out. Now, they just awkwardly mirror each other from across the Drake Passage. Classic exes.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American Plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a cabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
Lake Michigan is one of the largest and most mysterious freshwater lakes in the United States. And now, deep inside it, scientists have stumbled upon something unexplainable. Vast, round craters scattered all across the lake's floor. It all started in 2022. A team of researchers wanted to map the lake's bottom and look for some shipwrecks. At first, they were sure it's going to be just some typical rocky terrain or sandy patches. But what they saw on their sonar screens stopped them cold. Strange circular shapes that looked almost too perfect to be natural. They were hiding about 500 feet beneath the surface, in places where the water turns dark and impenetrable. Those guys are huge, ranging from 300 to 600 feet wide. They also plunge nearly 40 feet deep. And there are dozens of them, neatly arranged like some footprints. But the team had no idea what these things were. Then, in August 2024, the mystery only deepened. Using a remotely operated vehicle, they got a closer look at these formations. There were about 40 of them. No one had ever seen anything quite like this before in the Great Lakes. What could have created those craters? Could they be ancient? Perhaps remnants of some geological event lost to time? If that's the case, it's weird how long these holes have likely been sitting there, undisturbed. Theories started popping up. One possibility was that they could be sinkholes or dolines. Those are basically holes that suddenly appear in the ground when the surface layer collapses. The rock beneath the surface, often made of limestone, gets slowly dissolved by water over time, creating voids underground. When the surface of those voids can no longer hold its own weight, it caves in, and this forms a hole. Think of it like when you poke a straw through the lid of a drink. Sinkholes can be small dips or huge, spanning up to 2,000 feet. They can happen gradually or all at once. Sometimes they can swallow entire cars or even buildings. And Lake Michigan sits on limestone bedrock. It erodes pretty easily when water flows through it. Sinkholes like these have already been found in Lake Huron, and they look kinda similar. But there are some plot holes, no pun intended, with this theory. For example, it's wild how they all would be so huge. It's also weird and pretty rare for sinkholes to occur in a lake bed. They also kinda resemble a straight pattern. They seem to extend generally southward, forming a loose line, which is pretty weird. If these are sinkholes, then they're definitely not playing the usual geological rules. Though it might be some new, unusual process at play beneath the lake's surface that we haven't discovered yet. There's another theory though. Glaciers. Glaciers are wild rivers of ice. They covered much of the Earth during the last ice age, and they're incredibly powerful. While they might move slowly, sometimes only a few inches per day, they have such immense weight that they can reshape entire landscapes over thousands of years. Glaciers can grind and scoop the land beneath them. They're basically like colossal bulldozers. Their weight, combined with the slow but steady movement, grounds down everything beneath them: rocks, soil, even bedrock. This can create deep gouges in the Earth's surface, called glacial troughs. During the last ice age, there were lots of glaciers all over the northern US, including the Great Lakes region. If they moved across what is now Lake Michigan, they could have carved out these deep holes. Glaciers often move in a pretty straight path. As they move, they cause terrain to erode, but the resulting erosion varies based on terrain. Sometimes there are places where the bedrock is softer or fractured, and these places are more easily carved and crushed by the glacier. That could explain why some holes could be bigger and deeper than others. Harder bedrock is less affected. But usually this leads to rounded, crescent-shaped depressions known as chatter marks. Those marks are more like grooves rather than circular, big craters like those in Lake Michigan. Once the glaciers melted, the Great Lakes themselves formed. If the craters were formed by them, they may have filled with water, becoming part of the Michigan Lake. Though this theory is more like a speculation, so we need more evidence. But there's another layer to this mystery. The craters are not just curious geological formations. They actually may hold valuable clues about early life on Earth. Parts of Lake Michigan, especially dark ones, are relatively low in oxygen. It's like a lighter version of deep ocean environments that often have very little of this element. For example, hydrothermal vents deep in the ocean, underwater openings in the Earth's crust with some hot, mineral-rich water that are often very low in oxygen. But some organisms love places like these. For example, opossum shrimp. Teeny tiny shrimp-like creatures that love cold, deep waters. They get their name because they have a pouch to carry their young until they're ready to be on their own, like an opossum. Or deep-water sculpin fish, small bottom-dwelling fish that also enjoys cold lakes. They're well adapted to living in dark waters and usually stay close to the lake bed. And weird organisms like invasive quagga mussels, which kinda look like shells. These are small freshwater mussels that have spread there to the Great Lakes. They attach themselves to hard surfaces and can cause problems for ecosystems by competing with native species for food and space. All these guys could be in Lake Michigan, and even more. There might be microbes or even bacteria that are specially adapted to these harsh conditions, just like it was in Lake Huron. There's only a handful of creatures that could survive deep within these craters, and studying them could give us insight into how life once flourished in Earth's ancient, oxygen-poor oceans. That's because it's in places similar to these, where some of the earliest life forms thrived. Early Earth had an atmosphere with little oxygen, although it was much more hot, and ancient microbes adapted to this. The Great Lakes, especially Lake Michigan, have always had a bit of a ghostly reputation. Like even this mission was organized to study the shipwrecks. There were about 6,000 of them in the Great Lakes. Many of these wrecks are still sitting on the lake beds, preserved by the cold, fresh waters. And shipwrecks aren't the only strange things tied to the Great Lakes. Over the years, there have been stories of unexplained disappearances. Boats and even planes have vanished without a trace. The lakes, often calm on the surface, can suddenly turn dangerous with unpredictable storms and massive waves, leading to these mysterious events. Not even mentioning all the creepy stuff people notice there over the centuries, such as ghostly lights above water or bizarre weather patterns like eerie, sudden fogs that seem to appear out of nowhere. In 2007, they even discovered some prehistoric structure that looks like Stonehenge there. Well, it was way smaller, but still. It lay about 40 feet below the surface in the heart of Grand Traverse Bay, and it's speculated to be about 9,000 years old, way older than Stonehenge. Looks like this is a print of those who lived in the area thousands of years ago. These massive stones are arranged in a careful, winding pattern stretching over a mile. They range in size from basketballs to compact cars. But one, in particular, stands out. A boulder 3.5 to 4 feet tall, 5 feet wide. It's etched with the image of a mastodon, a creature that roamed the Earth about 11,000 years ago before it went extinct. It probably sank there during the end of the last ice age we mentioned. This period had reshaped the region. This place is underwater now, but back in the day, it was still dry land. So the stones were probably created by people who lived there, though we're not sure why. Were they used as hunting blinds? Or was it some sort of an ancient calendar? Who knows? Only about 15% of the Great Lakes floors have been explored. Now, scientists are gearing up for a deeper dive into this mystery, both literally and figuratively. They want to analyze the lake beds surrounding the craters, hoping that maybe something in the environment around them might have caused them to appear. They have initiatives like Lakebed 2030. These missions should map the entire underwater landscape. This would help us learn tons of interesting stuff about Lake Michigan and our planet's past. Who knows what other secrets these dark waters hide?
A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of two school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali Plate in the east and the Nubian Plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali Plate could split completely from the Nubian Plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift system. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift system. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift system's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's 8th continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the 4th largest island in the world, completely surrounded by water. But it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So, Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island that's 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent. And it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution, even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future. Summers in the Middle East get so hot that they change the landscape dramatically and make entire cities resurface from the past. That's what happened in 2018 when the city built by a mysterious empire on the Tigris River was finally released from its water trap. Archaeologists rushed to the location as they didn't want to miss a rare chance to excavate the site and learn more about the history of the place. They believe they've found the Bronze Age city Zakiku, founded over 3,000 years ago and fully submerged in the 1980s when a dam was built in its place. It used to be a busy hub for the Mitanni Empire for caravans on the popular trade route. It had water, which is a rarity in the area, and it was a guarantee for success. We know very little about the once powerful empire, as scientists haven't found any written chronicles in the excavated sites. That's why the archaeologists were thrilled to find an entire palace for the local ruler. Several years later, when the area became free from the water again, they found some fortifications to protect the city from foes. The highlight of their expedition was finding a huge public storehouse for trade goods and harvests, piles of wheat and barley, and imported metal and wood. Bread was the staple food for the locals, and they also loved big pots of vegetable soups and stews for lunch. Each household kept sheep, goats, cows, and pigs, so they had a steady source of milk and meat for special occasions. All the constructions found so far were built from bricks molded from mud. The walls that were underwater for over 40 years are so well preserved as if they went down yesterday. The royal palace stands out as it's larger than the other constructions, has thicker walls, and even pavements made of baked mud bricks that were sealed to be waterproof. The local king must have been in good relations with the emperor of the larger empire, of which Akiku was dependent. Traders who lived in the city collected wooden beams and took them to storehouses. The beams arrived down the Tigris River from the forests in the mountains in the north and east of Mesopotamia. Merchants came here to sell their goods and then crossed the Tigris on their way to the borderlands. Zakiku was thriving as a center of commerce for about 6 centuries, until it was hit by a massive earthquake in 1350. Archaeologists found 5 ceramic vessels holding over 100 clay tablets made close after the earthquake. It's almost a miracle that small tablets of unfired clay managed to survive underwater for decades. People who created those must have carved notes on clay while it was still wet. They wrote about anything, from newly stored harvests to notes for other kingdoms. Then they would let the message dry in the sun. Scribes even had to learn a different language so that everyone outside the city could read it. Scientists believe the tablets they found used to be part of a private archive. They hope to decipher the notes to learn more about the history of Zakiku and the whole empire after the terrible earthquake. The damage to the buildings was so enormous that it was impossible to restore Zakiku to its former glory, and if there had been any survivors, they must have left the city. Several decades later, the Assyrians, who also lived in Mesopotamia, settled here. They built their houses on the ruins of the abandoned city and used whatever structures they could find from the previous residents as outer walls. But they stayed here only for 50 years, then decided to build a new capital on more fertile soil to make some good cash from agriculture. Archaeologists working in Zakiku had to halt excavations when the water levels went back up and covered the city. They sealed the ruins in tight-fitting plastic sheets and put stones and gravel on top. They hope it will help protect the priceless site from water erosion and prevent it from disappearing again. They realize how important water from the dam is for the region, but if it recedes again, they say they'll definitely continue the excavations. There was a bustling community in today's Taklamakan Desert in China around 1,600 years ago. It lived along the Nile River, which ran through the desert for miles and got its water from the melting snow in the mountains. After 3 years of work in the area, archaeologists and scientists managed to dig up 8 tombs in the desert. Thanks to the desert heat, the clothes and artifacts inside them were almost as good as new. The people who wore those must have lived in the ancient city of Naya. Naya used to be part of a prosperous kingdom at the heart of the Silk Road trading route and had a population of over 3,000 people. Then, desert sands went rogue and swallowed the city whole. Archaeologists only found the ruins of Nija in the early 20th century. Scientists from different countries have tried to solve its mysteries. It looks like the tombs discovered at the end of the 20th century belonged to the wealthy. There were some expensive items inside: a quiver and bow, metal arrowheads, gold earrings, and a glass bead necklace, a lacquer box with a comb, makeup, and a sewing kit in one of the tombs. There was also some silk of top quality, and even the bright colors like green and yellow haven't faded on it. The fabric also had Chinese characters with quotes from historical books, which helped scientists identify the period in which it was made. Archaeologists later found a large dwelling site and the clearing of 3 ruined buildings. It will probably take many more years to understand why the city had fallen and what happened to its people. Saudi and French archaeologists teamed up near Riyadh, the Saudi Arabian capital, and stumbled upon an ancient settlement dating back 8,000 years. The scientists used all sorts of cool tech, like laser scanning, drones, and aerial photography, to unearth this Neolithic-era gem. They found the settlement in a local archaeological hotspot. Among the treasures they uncovered were a stone temple, remnants of an altar, and over 2,000 graves. All these finds tell us about ancient practices and rituals. The team also found the foundations of 4 massive buildings, corner towers, and open-air courtyards, all with underground reservoirs to store water for agricultural use. There was also a smart irrigation system with canals and cisterns, which let the city thrive in one of the driest deserts in the world. Rock drawings etched into the nearby mountain depicted the daily life of the locals. The excavations have been going on in the area for over 40 years, and scientists still keep finding new artifacts to answer more of their questions. Fishers have stumbled upon ancient bones, tools, and artifacts that are 9,000 years old on the North Sea floor. British and Dutch archaeologists and paleontologists rushed to see the finds as they were hoping it could be evidence of the submerged Doggerland. And they weren't disappointed. There were even perfect sets of footprints left by Mesolithic people who lived here. 12,000 years ago, during the last major ice age, the British Isles weren't islands at all. There was a landmass made of many hills, marshlands, and dense forests that connected them to the European continent. That landmass was Doggerland, where a prehistoric hunter-gatherer society lived and thrived. But then, the sea level started going up at the speed of 3 to 6 feet a century as glaciers were slowly but surely melting. The locals had to move to areas that today belong to England and the Netherlands. Experts decided to learn more about the history of Doggerland, using data from oil companies working in the North Sea. So far, they've created digital models of what the area of 18,000 square miles might have looked like before it vanished beneath the waves. They still need to analyze samples of ancient insects and plants and the DNA of animals to get a full picture.
There's a river in North America that shouldn't exist. Well, at least according to scientists. Most normal rivers in the world join downstream, flow downhill, and finally deliver their waters to an ocean or a lake. But the Ikememish River in Canada doesn't like to follow the rules and flows in both directions. Its name even means water that flows both ways, in the local dialect, Cree. The Ikememish is just around 37 miles long, but it used to be an important part of the fur traders' route from Hudson Bay to Lake Winnipeg. It runs between the Hayes River and the Nelson River. Its waters are rather shallow and dark as it flows through peat bogs. Things get interesting when you reach the beaver ponds. People who ventured there say the Ikememish flows toward both the Hayes and the Nelson Rivers, starting from the central beaver pond. It's hard to tell where exactly the water divides as the river goes through a nearly flat, swampy country, and its current is barely noticeable. The next river on our list is the Cassiquiare in South America, and it's like a hydrologic equivalent of a wormhole between two galaxies. It's the only natural canal on Earth that links two great rivers, the Upper Orinoco, which eventually flows into the Atlantic Ocean, and the Rio Negro, the largest left bank tributary of the Amazon River. This rare sort of division is called a bifurcation, and it happens when a single river splits and sends its water into two different places. The Orinoco actually loses parts of its water to the Cassiquiare. From there, the water slowly flows down toward the Rio Negro. During the rainy months, there is more flooding and stronger currents, so a larger amount of water gets diverted. For many local communities, the Cassiquiare is more than just a river. It's sacred. They see it as a path that the ancestral spirits made to bring the great rivers together. Other stories say powerful deities shaped the land to create this special waterway. The Wayambo River in Suriname can flow either east or west depending on its mood. Just kidding. You gotta blame rainfall and human activity for this unusual behavior. People put locks on the river to divert it. One lock, for example, is there to help the rice farmers get enough water. There are at least 3 bifurcation points in the river. It's tricky to control the Wayambo and to predict where the pollutants will spread along the river. It's close to gold mining and oil production sites, so it's a real problem. If you've ever wanted to drink water from two oceans at once, North Two Ocean Creek in Wyoming is the place to go. It begins high up in the Teton Range and later splits into two branches. The Pacific Creek joins the larger Snake River, which merges with the Columbia River, and finally reaches the Pacific Ocean. The Atlantic Creek heads east and flows into the Yellowstone, Missouri, and Mississippi rivers, and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers who were looking for the Northwest Passage between the two oceans never knew they could have used the creek. They would just need really tiny boats. Some scientists believe that cutthroat trout knew about this route long before people. They managed to migrate from the Snake River to Yellowstone River, most likely using this creek. The next star on our list could take over the mighty Mississippi. About 12,000 years ago, the Mississippi started drifting toward the basin of the Red River. The Mississippi stuck to its original path, and the water from the old Red River route became what we now call the Atchafalaya River. It used to be jammed up with logs for about 30 miles and wasn't fit for navigation. By the middle of the 19th century, European settlers cleared the logjam. But the flow of water changed so much that it could mess with the lower Mississippi River. So, people built special structures at the bifurcation to control the way water flowed between the rivers. At times, up to half the water from the Mississippi can get pulled down the Atchafalaya. You can see this massive amount of water even in satellite photos. Digital elevation maps and computer models also show exactly how the rivers split. If those control systems weren't there, the Atchafalaya would probably take over and steal most of the Mississippi's water. New Orleans could lose its main source of fresh water, and shipping along the Mississippi would take a big hit. The Arroyo Partido, meaning parted stream in Spanish, in southern Argentina, also carries its waters to two oceans at once. It starts high up in the Andes Mountains and cuts through a steep forest covered in trees. When it comes out of the canyon, it enters a wider area where a big, rocky outcrop sits right in the middle of the stream and splits it in two. One side of the stream, the left, turns south and eventually reaches the Atlantic Ocean. The other side turns north and flows into the Pacific Ocean. It's pretty unique because the bifurcation doesn't happen in a flat lowland, but in a mountain saddle. It's kind of like a dip between two mountain peaks. You won't find much about Arroyo Partido on most maps though. That's partly because the area wasn't well mapped until the late 1800s, and partly because the stream is small and surrounded by lots of bigger rivers and lakes that usually get all the attention. Also, there are no public water flow models available for this stream yet. Still, people have confirmed the split using aerial images and photos taken by hikers and travelers. A digital elevation model also shows that if you poured water right in the area where it's supposed to split, it would naturally flow both ways. Divide Creek is located on the border between British Columbia and Alberta in Canada. This stream flows down a mountain and reaches a saddle-shaped area called Kicking Horse Pass, where it splits in two. It happens because of Summit Lake, which sits just west of the Continental Divide. A long time ago, Summit Lake was much bigger and probably stretched across the entire pass, possibly causing the stream to split back then too. But over time, the lake got smaller and now only exists on the west side. It left behind a swampy wetland right at the highest point of the pass. Like Arroyo Partido, Divide Creek didn't show up on many old maps. It's small and the area is covered with thick forest, so even aerial photos don't clearly show the stream splitting. The best proof we have today comes from Yoho National Park, where a marker explains the bifurcation. It's placed along a hiking trail, and if you're up for an adventure, you can take a short side path that leads right to the spot where Divide Creek divides. Now, how about a lake for a change? Wollaston Lake is tucked away in the far northwest corner of Saskatchewan, Canada. The coolest part about it is that it also bifurcates. Near its northern end, about 90% flows into the Cochrane River and heads northeast, and around 10% flows into the Fond du Lac River and goes northwest. Where the water ends up, either toward the Arctic Ocean or the Hudson Bay, depends on which side of a long peninsula it's on. Maps and models show that there might still be some water flowing between the two sides of the peninsula, so technically it's not a perfect bifurcation, but it's still one of the most fascinating natural features around. The peninsula itself is slowly eroding, and eventually it might disappear. But geologists say that because of the Y-shaped layout of the lake, the water will keep splitting into both river systems no matter what. Even long before European explorers came around, the local people already knew how special Wollaston Lake was. They called it Lake Manitou, which means spirit. They believed the lake had supernatural powers because of its rare position at the top of two major watersheds.
Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle megafloods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together. Imagine you're driving across a bridge to visit a friend. The next day, you get in your car to go back, but there is no longer a river under the bridge you drove across yesterday. Believe it or not, this is exactly what happened to people in the south of Honduras when Category 5 Hurricane Mitch hit in October 1998. Choluteca Bridge, which the local authorities reconstructed earlier that year, was left in the dry, as the river now flowed around it, not under it. The structure soon became famous online as the Bridge to Nowhere. This waterway shifted its course overnight, but it normally happens over longer spans of time. A river will stop flowing straight when there is even the tiniest change in the landscape around it. Even something as tiny as a mouse can weaken a riverbank. Imagine a family of mice decides to start a home somewhere by the river and digs a cozy hole. Over time, water gets inside this hole and starts washing away any loose soil. Give it a couple of centuries, and the river will now have a bend in this place. And if you're worried about the mice family, don't be, because they moved out a long time before the water flooded their home. Things happen even faster for small streams because, well, their beds are also smaller. The current breaks down stones, the ground takes them in, and voila, a riverbed or bottom is formed. The current is the strongest in the middle of the waterway, and its power directly shapes the riverbed. The water flowing through rivers is full of soil and other particles. All this stuff goes from the spring into the mouth of a river and into Earth's oceans. In some cases, these particles build up at some point. And that's how new beaches, probably including your favorite, are born from fine-grained sand. On the other side of the river, the flow of water is much faster, so this fast-moving current literally slams against the next bank. Then, the process of erosion starts all over again. River erosion is what happens when the flowing water takes away soil. And I have to tell you, things go super fast there. That water is so energetic, it can even carve into rocks, creating a canyon. If the riverbanks consist of loose material, such as humus, that's the soil you plant a flower in, then it is easier for the flowing water to erode it. Rivers in the plains are often wide and slow because there's little resistance from the ground around them. So you don't have to worry about waves tipping over your boat on a flatland river. In the mountains, streams quickly wash away all the surface soil and gravel, revealing the bedrock beneath them. It's tightly bound, so mountain streams are literally set in stone, as they cannot wash away this bedrock. So we have erosion to blame for waterways changing their course, and also mountains and hills. When a stream reaches a mountain or simply a rock, it has two choices: to flow around it or carve its way through it. In flatlands, rivers don't have any natural competition, so they choose a more winding path. All this twisting and turning increases the river's total length from the source to the mouth. One such example is the mighty Mississippi River in the U.S. It has a lot of curves and bends, which are called meanders. In the last century and a half alone, the Mississippi changed its course several times. The last major case was in 1876 when it left the historic city of Vicksburg in the dry. 2 years later, a team of American engineers came to the area to construct the Yazoo Diversion Canal, which took 25 years to complete. Thanks to it, ships could once again sail to Vicksburg, reviving the town's economy. What happened in this southern U.S. town in the 19th century is an ordinary natural consequence of river erosion. The bends in a waterway grow sharper over time, making the water flow faster. This speeds up erosion, and individual bends slowly start approaching each other to the point they merge. When this happens, the river straightens up overnight, leaving a lake in the form of a horseshoe in the place where the bend was. This newly formed body of water is called an oxbow lake. These still water lakes either dry up, since they're no longer fed by a spring, or they turn into swamps. In some cases, humans use them as water meadows used for agriculture. Lake Shakot in Arkansas is the largest oxbow lake in North America, formed by the Mississippi several centuries ago. The source of the Mississippi is a lake in Minnesota, but a river can also start when two other watercourses become one, or when the water simply bubbles up from under the ground. Even melting snow can feed a river, like the Amazon gets its water from the Andes. Determining the source of a waterway can be tricky, so the debate about whether Amazon or the Nile is longer is still ongoing. What scientists know for certain is that the Amazon carries more water than any other river. 1/5 of all the fresh water that enters Earth's oceans comes from this South American river. When you look at the Amazon River on a map, you'll notice how it flows from Peru to Brazil, that is, from the west to the east. This direction might seem odd when you compare it to the Mississippi, which flows to the south on the map. It's so confusing because you probably know rivers flow down, affected by gravity, but down doesn't automatically mean south. Running water will try to find the easiest route down, so there are no rules in terms of cardinal directions. The Nile River is the best example of this, as it actually flows north into the Mediterranean Sea. Northern Egypt, where all those pyramids are located, is on lower ground than Sudan, where the Nile is formed when the Blue Nile and the White Nile merge. Ob in northern Asia and the Mackenzie River in Canada both flow northwest, while the Yellow River in East Asia flows in the same direction as Amazon, to the east into the Pacific Ocean. These major rivers are some of the best examples that a stream doesn't have to flow from the north to the south. Gravity is the only important factor that determines which way a stream will flow, as running water is all the time pulled downwards. The flow of water is faster on steeper slopes. When there's a sudden drop in the flow, waterfalls form. Angel Falls in Venezuela is the highest waterfall on the planet, with water dropping from a height of 2,600 feet. Watch your step. In a waterfall, the falling water can easily reach the speed of a Thompson's gazelle, but as a river approaches the end of its journey, it slows down significantly. The stream doesn't have enough energy to cut into the nearby land. All the sediment it has picked up along the way, such as sandstone, slows it down. At the place where a river meets the ocean or a lake, it gets rid of this sediment along its banks, creating a delta, an area rich in fertile soil. The Ganges in India has the biggest delta in the world, several hundred miles wide and visible from space. The Amazon, on the other side, doesn't have a true delta because the strong currents of the Atlantic Ocean wash away everything the torrent brings. The deepest section of the riverbed that runs along its middle is called a channel. This is where the current is the strongest, so ships travel on top of these channels. When engineers want to expand a waterway, they simply dig a deeper channel and voila, larger ships can now pass. This is just one way humans alter watercourses. We often strengthen the banks of a river to prevent erosion or build dams that stop or divert the flow of water. The oldest operational dam on the planet dates back to the time of Egyptian pharaohs. It was, of course, the first damn thing. Well, this eerie Lake Huron discovery may be that it possibly contains the remnants of an entire civilization. Whoa, wait, sounds like Atlantis, right? Well, not exactly. But if there really had been an ancient underwater civilization here, it must have been a pretty advanced one. Around 10,000 years ago, two sharp glassy flakes broke off a stone tool and landed on the ground unnoticed. They stayed buried there for thousands of years, until 2013. Then scientists pulled up a small chunk of mud, about the size of a milk carton, from the bottom of Lake Huron, 100 feet underwater. Inside the mud, they found those same two flakes made of obsidian, a shiny black volcanic glass that forms when lava cools quickly. After careful testing, they realized these flakes came from Central Oregon, which is quite a distance, about 2,500 miles away. They found this prehistoric Great Lakes site on the Alpena Amberley Ridge, an underwater landform that once connected what's now Michigan and Ontario. Back then, it was dry land. Early humans used it to build traps for animals like caribou as the Ice Age faded and the Great Lakes began to form. Now, obsidian was the high-tech material of ancient times. It's super sharp and perfect for making tools. If you study the flakes carefully, it's obvious that humans made them. You can see where they struck them and the feathered edges that come from being carefully chipped. That means people were not only crafting tools here, but they also had access to obsidian that came from incredibly far away. It was likely possible through a huge trade network that spanned across the continent. For over 100 years, people have guessed that ancient societies might have existed beneath the Great Lakes, but no one had proof. That's why work on this submerged archaeological site is so important. A team of researchers has been trying to learn more about the 10,000-year-old ruins and the civilization that left them behind for over a decade now. Lake Huron's icy water acted like a time capsule that helped preserve things for thousands of years. So far, researchers have found not only unique stone tools, but also ancient trees with roots still intact and underwater peat bogs that preserved seeds and leaves. It was like an Ice Age version of Pompeii, a scene frozen in time. These discoveries are also helping scientists create new technologies and ways to do underwater archaeology. They've engaged sonars, underwater robots, and divers so far. Now, it's pretty cool that the tools they found on the Alpena Amberley Ridge were way smaller than other tools from the same era found nearby. That might mean a different group of people lived here, and they had their own unique way of life. Even the peat bogs they found, which are about 9,500 years old, hold secrets. They're full of pine needles, seeds, and leaves that could reveal what the environment was like back then. Usually stuff like this breaks down quickly on land, but the cold freshwater preserved it. The Michigan team is working with scientists in Cambridge, England, to extract DNA from the remains. If it works, it could finally confirm what animals lived there, and maybe even more. There are still years of discovery on this prehistoric Great Lakes site ahead. Another famous submerged archaeological site is the lost city of Pavlo-Petri. Archaeologists think it is the oldest sunken city in the world they've found and made official so far. Pavlo-Petri is around 5,000 years old. That means it existed even before the legendary Greek heroes in Homer's stories. Scientists first spotted it way back in 1904, and then mostly forgot about it until 1967, when Nicholas Fleming rediscovered it. He described it as a Bronze Age city now lying under about 10 to 13 feet of water. A year later, he returned with a team of scientists to study the ruins. Over 6 weeks, using just hand tapes and a basic grid, they managed to map out the city. They found that it covered almost 1,000 feet by 500 feet and had at least 15 buildings, courtyards, 5 streets, 2 tombs, and around 37 small stone graves. They also found signs that the ruins continued onto the nearby island of Pavlo-Petri itself. They dug up some amazing pottery, obsidian, and chert blades, and even a tiny bronze figurine that may date all the way back to 2800 BCE. Most of the buildings, though, came from the period between 1650 and 1180 BCE. Then scientists left the site alone again until 2009, when a super team of researchers launched a new 5-year project to really dive deep into the history of Pavlo-Petri. This time, they had digital mapping tools and better diving equipment, so they could explore and even excavate underwater. They found another 97,000 square feet of buildings, including a large hall and hidden streets. Plus, they dug up even more pottery that showed people had been living in the city from about 3000 BCE to 1100 BCE, and that the city once had a population of 500 to 2,000 people. No one knows for sure how the city ended up underwater, but many scientists think it was because of an earthquake, maybe around 1000 BCE, or even as late as 375 CE. Because it's the oldest underwater city ever found, some people even believe Pavlo-Petri might have inspired the legend of Atlantis. Another contestant for the Atlantis title lies near Japan. Back in 1986, a local diver was exploring the waters near the Ryukyu Islands when he found a giant structure made of perfectly shaped steps and sharp edges. It was 82 feet underwater. Today, the Yanaguni Monument is one of the most mysterious underwater sites on the planet. The structure is nearly half a football field in size. It looks like a massive stone pyramid with layers of platforms and steps stacked one on top of another. No one really knows where it came from or who built it. Some experts think the monument might be more than 10,000 years old, which would make it older than the Egyptian pyramids. One theory is that it could be the last remains of a lost civilization called Mu, a mythical Pacific society kind of like Atlantis. Others believe an ancient culture that lived in Japan as early as 12,000 BCE might have built it. But many scientists and geologists are skeptical about this possible underwater ancient civilization, even though Yonaguni has narrow passageways, arched openings, and right angles that almost look like city blocks. They say that the site looks a lot like natural rock formations, like the Giant's Causeway in Northern Ireland, for example. The whole monument is still connected to a bigger chunk of bedrock, which means it wasn't built piece by piece. And the way the layers of rock are stacked probably has more to do with earthquakes and tectonic movement. It's located in the very active Pacific Ring of Fire. One marine geologist kept going back down there, and every time he found something new. He says he spotted tool marks in the rock, symbols carved into stone faces, and even rock formations shaped like animals. He believes these carvings point to a culture that came from mainland Asia. He said he had identified 10 different structures off Yonaguni, including a ruined castle, a triumphal arch, 5 temples, and even a huge museum. These buildings seem to be connected by roads and channels, and some parts are surrounded by what could be giant stone walls. The explorer believes the city is at least 5,000 years old, based on stalactites found in underwater caves nearby, which would have only formed after the caves flooded. His supporters say they have never seen an earthquake create shapes like this, above or below water. But skeptics blame it all on erosion and insist that whirling underwater currents and sea creatures left holes in the rock. Now, if you want to form your own opinion about it, the spot is open for visitors, and it's definitely a super fun diving experience. Hey, you've heard of Stonehenge? Of course you have. Big rocks mysteriously mounted in circles on a plain in England by, somebody. But what if England's Stonehenge is only a replica of another monument, and its builders just crossed the Atlantic and copied what someone had already done elsewhere? Well, it turns out researchers found another Stonehenge underneath the waters of Lake Michigan. This lake is a hotspot for woo-woo unexplained things. A bunch of disappearances, plane crashes, and now this, an ancient underwater monument that looks strangely enough like Stonehenge. We couldn't help ourselves and needed to dive deep into the story. A ring of massive stones, arranged in a way that felt all too familiar. They saw 2 circles, an outer one and an inner one, sitting 40 feet below the surface. But this wasn't just a random pile of rocks. These stones had been placed there, purposefully, by human hands. And by doing some further research, they discovered that they were staring at a structure that's over 9,000 years old. Think about it. This Stonehenge beneath Lake Michigan predates the pyramids. It predates Stonehenge itself by about 4,000 years. All of this information was enough to startle scientists at Northwestern Michigan University. But that was before they found this out. One of the stones had a carving, a faint but clear petroglyph of a mastodon. Mastodons kind of look like the ancestors to our modern-day elephants, but they have been extinct on planet Earth since 10,000 years ago. So, whoever built this underwater Stonehenge needed to be alive at the same time these creatures roamed our planet. This discovery raised many questions among scientists. I mean, why on Earth would they go through all this trouble to lay rocks at the bottom of a lake? Well, first things first. Scientists believe that Lake Michigan had much less water back then than it does now. Second, it could have something to do with ancestral practices of First Nation people. There's one theory from a professor of the University of Michigan. He suggested that the stones formed a kind of prehistoric hunting trap. He believes that early hunters used the circular formation as a drive lane to herd large animals like the mastodons from the rock carvings we were just talking about. Once they got these huge animals into a tighter circle, they could be more easily hunted. But not everyone's convinced by this theory. Some believe the circle probably had a deeper spiritual purpose. According to local Native American tribes, like the Anishinaabe, stones are more than just rocks. They're living beings. They hold spiritual energy and represent a connection to the earth and all living creatures. An elder from the Anishinaabe community even suggested that these stones are sacred, placed there by their ancestors to honor the land and its creatures. Scientists are trying to study the stone formation in depth, like about 40 feet. But that's the problem, actually. The fact that it's underwater makes it super difficult, since they don't have the best technology. Traditional archaeological tools don't work as well when everything is submerged, but promising new technologies like stereophotogrammetry, which literally means making 3D models of a site, are helping scientists study the stone circle more closely. Still, research is slow and expensive, so it's hard to know when this mystery will come to a close. As we said, Lake Michigan is a hot spot for unexplained phenomena. Its lakebed is filled with shipwrecks, such as the Thomas Hume, a sturdy American schooner. It also collects debris from airplanes that have suddenly gone missing while flying the area, such as Northwest Airlines Flight 2501 that disappeared in the 1950s. Some people even call the area the Lake Michigan Triangle, suggesting paranormal activities like what happens in the Bermuda Triangle might be going on. The lake spans over 22,000 square miles, which means it's almost two-thirds the size of the country of Ireland. In 2024, scientists were able to access another one of Lake Michigan's mysteries, the wreck of the Margaret A. Muir schooner. This 130-foot-long sailing ship sank over 130 years ago. The discovery was announced just recently by the Wisconsin Underwater Archaeological Association, the WUAA, whose team found the shipwreck sitting 50 feet below the surface just off the shores of Algoma, Wisconsin. Built in 1872, the Margaret A. Muir was a three-masted schooner built to carry heavy cargo across the Great Lakes. Her final voyage started out as a routine trip. Loaded with bulk salt, the ship left Bay City, Michigan, heading for South Chicago, Illinois. But on September 30th, 1893, things took a bad turn. Just as the Muir approached the town of Annapolis, now known as Algoma, a sudden storm hit. The ship began taking on water fast. The captain of the boat ordered his crew to abandon ship, and thankfully, they all made it to shore safely. For more than a century, the wreck sat undisturbed on the lakebed, its location a mystery. But thanks to a combination of historical research and high-resolution sonar, WUAA searchers finally found her in May of last year. The wreck is remarkably well preserved, with parts of the deck and gear still visible. Well, just a few lakes over to the left, researchers uncovered another impressive thing. At the bottom of Lake Mendota, near Madison, Wisconsin, researchers found 11 ancient canoes. They believe the oldest of the canoes dates all the way back to 2500 BCE. Now, if you don't get why that's important, it's because you're thinking with today's head. If in a classic Midwest highway you see a bunch of pickups, then back in the ancient days you see only canoes. They were the main mode of transportation for indigenous cultures. They were used to fish in deep waters, trade goods, and travel long distances. The reason why scientists were so excited with this discovery is because they had never found any proof of what canoes were being used for in this region back then. And to understand the local cultures that inhabited the area during this time period, they needed to have some information on that. This exciting discovery was announced by the Wisconsin Historical Society in May 2024. The first canoe, which they believe is around 1,200 years old, was pulled from the lake in 2021. Then a second one was dug up in 2022. And now divers have found at least 11 more canoes along what would have been an ancient shoreline, long since submerged. One theory is that these canoes were intentionally sunk to keep them from freezing or warping in winter. It's possible people stored them in the same spot for generations. Or maybe this is just a small part of a much bigger settlement. Historians do believe there could be an ancient village hidden under the water of the lake. Divers have already found stone tools, like net sinkers used for fishing, but the village itself hasn't been located yet. Truth is, while the Great Lakes often steal all the thunder, scientists point out that smaller lakes like Mendota have stories too. The Wisconsin Historical Society is working closely with Native nations to piece together more about the lake's history. You'll need to believe me when I say there is a third Stonehenge, all the way under the waters of Lake Constance, Switzerland. I mean, think of it like Stonehenge's cousin. Archaeologists began to discover this back in 2015, when they found a line of 170 man-made stone cairns under the lake. Scientists say this was most likely the work of several villages, and that the cairn site was probably used for some collective purpose because, well, the formations are huge. Some of them are several dozen feet wide, and they can build up to 6 feet. The most amazing discovery so far is that the site dates back to around 5,500 years ago. So around the time the original Stonehenge was being built. Some of the facts that link them together are their construction dates, as well as the distinct characteristic of stone monuments built in a circular format. Scientists don't know much about this site yet, but hey, I see a pattern manifested all over the world, don't you? There you are, trekking across a desert on foot. It's hot, you're terribly thirsty, and now you gotta walk around this stupid wall. Wait, a wall in the middle of a sandy, lifeless nowhere? Exactly, a wall in the northern Saudi desert. Archaeologists have just made a super exciting discovery, and what they found was not just a single wall. No, it was a whole ancient walled city that might date back to 2400 BCE. They think this place was home to around 500 people and could have been used for 1,000 years. This discovery is groundbreaking. It means that the area could have been way more advanced than anyone expected. This city was well organized, with different zones for living, towers and strong walls for protection, and different sections for all kinds of daily life. This ancient city, now called Al-Natab, was basically an oasis town, and it's great since it can give us a peek into what life might have been like in this desert thousands of years ago. Apparently, they had clearly separated areas, like residential sections, a cemetery, farmland, and even a town center. This oasis city, found in the Khaybar area, is the first big organized settlement from the 2nd or 3rd millennium BCE that researchers have uncovered in northwestern Arabia. The first survey showed that this town, which covered about 6 acres, had several districts, including the residential area, the cemetery, and the legal one, with courts. The houses were set up in neat rows, all connected by small roads. Those streets kept the residential area separate from the rest of the town. Back then, most people in this region were nomadic herders, always moving around. But archaeologists have been sure that during the Bronze Age, northwest Arabia had small walled towns and oasis centers scattered across it. These connected oasis towns were unique, offering secure places for people to live, store goods, and trade. They started showing the beginnings of urban planning, which hints that people of that time were already starting to settle down and organize communities more seriously. The research team estimated that there were about 50 homes in Al-Natab, but that number could go up to 70 as they keep digging. They think that a few hundred people lived there, and probably one of the coolest things is that some houses went up to 3 stories tall. Built on a slope near a couple of major trade routes, this city was set up in a prime spot. Now, one of the most impressive things about this place is its water supply. The oasis had springs and aquifers, which are underground water sources, and such conditions were perfect for farming. Those water sources meant residents could grow their own food, making the town self-sufficient. The outer walls probably helped control who could enter the town and get access to its resources. This settled way of life was an impressive shift from nomadic living to a more agro-pastoral lifestyle, which means a mix of farming and herding animals. Another find that supports this theory is a bunch of tools, like grinding stones, mortars, and pestles, discovered inside the town. People there must have ground grains and prepared food. They had a diet of cereals, meat, and milk from animals they raised themselves. These astonishing findings show that the inhabitants of the town could easily feed themselves and were surprisingly advanced for that time. Thanks to better access to Saudi Arabia in the past couple of decades, archaeologists now have a much clearer picture of what life there was like thousands of years ago. The most exciting thing is that Al-Nata might have been part of a whole network of similar fortified oasis towns spread across the region, and all of these connected sites could show us how trade routes and small settlements worked together at that time in that arid area. Now, at the same time, this recent discovery isn't the only one that has the scientific world buzzing with excitement. How about we visit Egypt and see for ourselves? After all, archaeologists have just found a stash of ancient Egyptian and Greek treasure underwater. They were exploring the lost city of Thonis Heraklion off the coast of Egypt, which sank more than 1,000 years ago. This city was legendary, and nobody even knew where it was until it was rediscovered in 2000. Now they're uncovering more and more, and on this dive, they found a pile of gold and silver treasures. Those were probably used in rituals to bless Egyptian pharaohs when they took the throne. The researchers even found an ancient Greek temple dedicated to Aphrodite and some super old Greek weapons. Frank Gaudio, the lead archaeologist, said it was astonishing that those delicate objects had survived the disaster that brought the city down. Back in its prime, Thonis Heraklion was one of the biggest port cities in the Mediterranean. It was a huge center of social life and was the main entry point for ships from Greece coming into Egypt. But tragically, due to rising waters, earthquakes, and a catastrophic tidal wave, the soil underneath the city literally turned into mush, and then the entire city sank into the Mediterranean. It was forgotten until Gaudio's team found it in 2000. Since then, they've been uncovering new parts of the city and piecing together its history little by little. If a lost underwater city doesn't seem impressive enough, we can travel to the Amazon. The discovery made there is truly mind-boggling. For centuries, people have talked about lost cities deep in the Amazon, like El Dorado, that mythical city of gold that lured Spanish explorers into the jungle. A lot of them never came back. Then, in the 1900s, a British explorer named Percy Fawcett went searching for what he called the lost city of Z, and he too disappeared. But now, finally, scientists have actually found proof that those lost cities in the Amazon were real all along. A team of scientists use a tech called LiDAR, which basically allows you to see through thick jungle from above by bouncing light beams off the ground. They flew over the jungle in Bolivia in a helicopter about 650 feet up and mapped out those hidden ancient cities. What they found were ruins of a huge urban settlement built by the Kasarabi people who lived there from 500 to 1400 CE. And it wasn't just a couple of buildings here and there. No, the LiDAR maps revealed massive urban centers, pyramids, platforms, roads, canals, and causeways, all carefully laid out. Turns out the Amazon wasn't just an untouched jungle. It was once home to big, complex cities. A scientist from the German Archaeological Institute explained that Europeans had long ignored the possibility of ancient Amazonian cities, but the LiDAR maps showed they were wrong. The new maps have revealed 26 sites, including 11 that no one even knew existed. Researchers have discovered two main city sites, Landivar and Kotoka. They had massive moat causeways stretching out like spokes on a wheel, linking the main cities with smaller surrounding settlements. Some of the canals even connected the cities to rivers and a big lake, which allowed water to flow through the area. Over the years, scientists found scattered ruins all over this region, but the thick jungle made it nearly impossible to connect the dots and see if or how they were related. With LiDAR, the whole layout came to life, showing that those sites were part of a much larger organized urban system. It's now also clear that the sites had a greater meaning, since everything is lined up in a way that could be symbolic of the spiritual beliefs of the inhabitants. The Kasarabi culture isn't as famous as the Maya, but they had a thriving society in an area that faced huge challenges, like yearly flooding. And although the nearby Andes had their own monumental sites, the Kasarabi were doing something absolutely unique. They even had reservoirs to store water, which suggests they might have been dealing with occasional droughts, which is pretty unusual for the Amazon. Actually, those terrible droughts could be why the Kasarabi eventually left their cities around 1400 CE. Humans invest a lot of time and money exploring the unknown. First outer space, then the ocean floor. But there's another frontier we're trying to conquer. Scientists call it the deep frontier. I'm talking about how far down to the Earth's core we've made it so far. During the 60s, humans tried digging the deepest man-made hole on Earth. This took us deep into the Arctic Circle. What later became known as the super deep borehole is also the deepest artificial point on Earth, reaching the depth of 40,230 feet. It took 20 years to drill this far into the Earth's crust, and researchers say this is only about 1/3 of the way through to the mantle. Here's a quick anatomy of our planet. If the Earth is like an onion, the crust is like the thick skin of this onion. This part is only 25 miles thick. Beyond this is the 1,800-mile deep mantle. And after that, right at the center of the Earth is the core, which is made up of 2 layers, inner and outer. Now, can you guess where on the planet the crust is at its thinnest? On the ocean floor. When American scientists understood that, they started drilling holes on the seabed. This gave way to Project Mohole. It began in 1961, but their technology to drill deep holes on the ocean was really bad. They had to improvise. They installed a system of propellers along the sides of their drill ship to keep it steady over the hole. The main challenge was to drill as vertically as possible. Otherwise, that deep hole would look more like a deep maze. Both the Kola Super Deep Borehole project and the Project Mohole came to an official stop in the years that followed. But hey, humans have built some pretty deep stuff underground. In 1963, a Turkish man took a swing with his sledgehammer to improve his basement and discovered a tunnel. That tunnel entrance led to more openings that connected a multitude of halls and chambers. He didn't know it, but he had discovered Deringoyu. This once lost city was up to 18 stories tall and 200 feet deep. The city was large enough to host 20,000 people, and it was simply standing beneath Cappadocia in Turkey the whole time. Cappadocia hosts hundreds of subterranean dwellings. 40 of these underground cities are at least 2 stories high, but none of them are as huge as Deringoyu. There's not a lot of historical accounts of how Deringoyu was born. Some speculate that the oldest part of the complex was dug about 2000 BCE by the Hittites. The Hittites were an Indo-European civilization who formed one of the first major civilizations of the Bronze Age in West Asia. Scholars think they built this underground city to protect themselves from invasion. Others think it was actually the Christians who built the city in the 1st century CE. They speculate that it could have been constructed to protect people from the intense temperature variations, extreme heat in summer and freezing cold in winter. Geographically, the terrain under Cappadocia is great for building. The rocks are soft, which makes tunneling easier. For that same reason, opening large caves underground is fragile. That's why most chambers have pillars that support them. On the bright side, and we are, none of the floors at Deringoyu have ever collapsed. The builders of Deringoyu thought of everything. The city was shut off from the world by huge rocks that hid its entrance. It was ventilated by a total of more than 15,000 shafts, around 10 centimeters wide. This way, they guaranteed enough breathing air in the upper levels in a way that they ended up being used as the living and sleeping quarters. The lower levels of this impressive maze were mainly used for storage. But honestly, they had it all. A room for a wine press, for domestic animals, small religious buildings. They certainly didn't spare any efforts to make that underground city as complete as an above-ground one. Now, speaking of impressive underground stuff, Switzerland has the longest tunnel in the world, built here on the Swiss Alps. This absurdly huge tunnel was built over 8,000 feet below the surface. Check this out. This is what the Gothard Base Tunnel looks like. The first idea to build the tunnel was put forward as early as 1947, but construction only officially began in 1999. It took them years to approve the project and then scout for the perfect location. Even so, the 73 different rock types that compose Massif turned the construction into a real challenge. Some of the rocks were as hard as granite, and others were as soft as sandstone. This meant they needed different approaches and equipment so the whole thing wouldn't crumble down. Overall, they had to excavate about 28 million metric tons of rock to make way for the tunnel. There were many other challenges to build that far into the Earth. The deeper into the mountain they got, the hotter the temperatures were. Since there's no natural ventilation, temperatures would get as high as 115 degrees Fahrenheit, making it really hard for workers to endure. The tunnel stretches for 35 miles from one end to the other. During the construction, workers had to use 4 massive tunnel boring machines, aka moles, to penetrate through the massif. Each of these moles was around 1,400 feet long. But that was one of the best things they could do, since these machines limit the disturbance to the surrounding ground and help to produce a smooth tunnel wall. You'd never guess that the world's deepest basement belongs to the Sydney Opera House in Australia. The building goes as deep underground as it grows above ground. But this basement isn't just the Opera House's foundation, it's a parking lot. This unique parking garage penetrates 120 feet underground, or 12 stories deep, while most car parks are only 4 or 5 stories deep. But that's not all that makes it unique. You see, if they decided to build a normal rectangular parking space, this would end up eliminating a bunch of possible parking spaces. And since they wanted to maximize the space they had available, they had to come up with some superb structure. First, they opened up a man-made cavern to make that dream possible. Then they had to come up with a design. That's what led to the donut-shaped cavern, or what engineers call a double helix. This design shocked the engineering community for its innovative approach. But hey, it worked! Today, there is space for over 1,000 cars down there, which seems about right for an opera house. Let's wow once again real quick. Some underground structures may take up to an hour to reach. Take this gold mine in South Africa that lies around 2.5 miles below the surface. Yeah, you may think, hey, it's just a couple of miles, why does it take an hour to get there? But the conditions are hard and it's not for the weak. But Milan Ladina, an Ecuadorian runner, even completed a half marathon there, despite temperatures reaching 104 degrees Fahrenheit, high humidity at 80%, and an atmospheric pressure of 1.4, comparable to what divers experience 5 meters under the sea. Yikes! Right after its creation, the cosmos was shrouded in darkness. I mean, I wasn't there, but that's what most scientists are thinking. All of the stars were hidden behind a thick cloud of primordial gases. Then, all of a sudden, something cleared up this fog, and the universe started shining, as it finally woke up. But how did this happen? 8 faint, recently discovered galaxies might hold the answer. The Big Bang created our world around 13.8 billion years ago. At first, it was just a super hot and chaotic boiling soup of particles. But over time, things cooled down, and particles could finally stick to each other. That's how the atoms appeared. Some helium, but mostly hydrogen, the very first element. And these first elements started creating thick gas clouds, which were very opaque. Then the first stars started forming. They were incredibly bright, emitting lots of light, including ultraviolet radiation. But even though these stars were shining, much of their light couldn't travel far because of that nasty hydrogen fog. The gas clouds absorbed and scattered any little light particles around. It was like the light was trapped around the stars. The Dark Ages lasted for hundreds of millions of years. Then, everything changed. Recently, the James Webb Space Telescope has spotted ancient dwarf galaxies from that epoch. Turns out, They're the ones we should be thanking for lighting up the universe. Back then, they were filled with early stars. These stars emitted tons of radiation that was so powerful that it managed not to just overcome, but break apart the hydrogen atoms in the fog. It turned them into charged particles, like particles that carry a little bit of electricity called ions. Little by little, the fog was cleared away. This process of clearing out the fog is called reionization, and this beautiful time is known as the epoch of reionization. Finally, the light was able to travel to all corners of the universe, which was a game changer, just like humans' Age of Enlightenment. To find these little igniters, astronomers used a technique called gravitational lensing. Imagine light traveling through space like a straight beam. But just like everything in our world, even time, light obeys gravity. If it's too strong, it'll literally bend the light beams. So when the beams pass near a massive object, the object's gravity pulls on them, curling and twisting their path. That's why black holes look so creepy, as they stretch stars and space around them like some whirlpools. But it's not that creepy. A regular glass or magnifying glass does something similar, hence the name gravitational lensing. When the lensing object is horrifyingly massive, it bends the light into multiple images of the same object, creating a creepy and mesmerizing structure called an Einstein ring. But if it's not that big, then the bending is less dramatic, and it just slightly distorts the shape of the background object, making it look kinda stretched. Gravitational lensing also helps scientists study things like the spooky dark matter. If the light looks stretched, and it's not just because of some obvious massive objects nearby, then it might be something invisible and heavy bending it. Since these 8 galaxies were too faint, no wonder they're almost as old as my unread emails. Scientists had to use these gravity tricks to observe them. The team studied light from galaxies that are over 13 billion years old. Finally, they focused on a galaxy cluster called Abell 2744, also known as Pandora's cluster. And these findings helped them understand how even little fellas played a huge role in transforming the early universe. The James Webb Telescope is an incredible tool, and soon it might help us look at even earlier times, at the cosmic dawn, when the universe was only several millions of years old. Another great tool, called the Roman Space Telescope, is going to help it. It's also possible that these galaxies weren't the only helpers in this entire saga. These early massive stars were absolutely terrifying. They just don't make them like that anymore. Some estimates suggest they were 30 to 300 times more massive than our Sun, and millions of times brighter. Modern stars have some heavier elements in them, but back then, they used only the stuff available, hydrogen and helium, which is why they were so hot and shiny. But they also had very short lifespans, lasting just a few million years. For example, our Sun is 4.6 billion years old and is still going strong, thankfully. At the end of their lives, they went supernova. These colorful bursts of energy were so strong that they forged the first heavier elements in our world and spread them across the universe, planting first seeds for the future planets. Meanwhile, the stars themselves didn't just disappear. They collapsed under their own gravity, creating the first black holes. Now, the black holes are also known for producing insane amounts of radiation, so it's possible that they might have helped speed up the clearing of the fog. Ironically, they help the universe shine brighter while sucking up the light at the same time. Recent discoveries show that black holes might be much older than we used to believe. They probably helped new stars and galaxies form. They were millions or even billions of times the mass of the Sun. The James Webb Telescope has already found a pair of early quasars. That's what we call the bright centers of galaxies powered by supermassive black holes. It's a curious pair of quasars that are merging just 900 million years after the Big Bang. This might be the earliest and most distant pair of merging quasars ever found. The telescope has also been studying things that are called cosmic lighthouses. In scientific language, they're pulsars. Pulsars are super-dense remnants of massive stars. They form from stars that were once 4 to 8 times more massive than our Sun. One of the greatest things about them is how fast they spin. They're one of the fastest objects in the universe. They might do around 700 rotations in just 1 second. They got their name because they behave like lighthouses, basically flickering radio waves. These beams of radiation sweep across the sky, creating a pulse-like signal that we detect. Now, a star basically works like this. There's nuclear fusion happening inside of its core. Atoms get fused in each other, move at crazy speeds, bump, all meanwhile releasing an unbelievable amount of energy. That's why they emit tons of light and heat. Of course, all this pressure tries to push outward, sweating like crazy to expand a star. The greatest the fusion is, the more powerful and insane the star gets. On the other hand, there's gravity that's pulling inward, trying to compress the star and keep it a nice small dense ball. As long as there's balance, the star keeps living. But when it gets old and spends all of its nuclear fuel, it becomes too weak to generate the energy it needs and can't fight against gravity anymore. That's when it basically collapses under its own weight, going supernova. What's left behind is the star's core, but now it's crushed down to an incredibly small size, about 12 to 17 miles across. It's roughly the size of a city. This dense core is known as a neutron star. The material in a neutron star is so dense that just a teaspoon of it would weigh as much as 4 billion tons, like 10,000 Empire State Buildings. And all this collapse sets off a trigger, causing the neutron star to spin super fast, creating a pulsar. It's kind of like when an ice skater spins faster when they pull their arms in. Pulsars often have a smaller star friend orbiting them, although it's not always a friendly relationship. Not long ago, astronomers discovered a pulsar that was surrounded by lots of energetic material for some reason. They realized that all this material was the remnants of another much larger star. Turns out, the pulsar had been slowly destroying its friend with its terrifying radiation and particles until it basically ate the neighbor away. It's similar to how a black widow spider consumes its mate. So, systems like this were called black widow pulsars. In any case, these lighthouses most likely help the reionization process as well. A long time ago, they could be very energetic stars in small galaxies and could emit enough radiation to transform the early universe. The James Webb Telescope's mission is to find more of these lighthouses and see what role they played in the universe's evolution. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want